Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Scripture, the Bhagavad Gita, Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome, everybody. Welcome to the live stream. And yes, of course, Yahtzee, chat. Yahtzee. Guys, thank you for being here. There are a lot of things going on. And so before we start our special edition of Hard Truths, Cold Fusion edition debate between Michael Perrone and Bob Greenyer, we are still waiting on one of our guests at the moment. I decided I would jump in because there's some stuff to react to. So let's give the people what they want. So the big news just last night was that a picture started circulating all over on Twitter. And in this image was Joe Rogan sitting at a table with Puthoff. Wow. That's big. Because if you've been following my work closely, I've been saying for over a year that Puthoff is the key to all of this zero-point energy. He's the godfather of zero-point energy. And I even shared a private direct message, my last private direct message to Joe Rogan after the whole Joe Rogan canceling out on me coming on saga that said, thanks, I appreciate you, but talk to Puthoff. Puthoff's the guy you should talk to. Now, in that period of time, what we've learned is there's no chance in hell Puthoff's going to talk, and probably not go on Joe Rogan either, because he just has too many NDAs. He's worked for the private military contractors. He's worked directly for the government. He probably knows all the secrets. And he's probably got one of those NDAs that's like, we can kill your whole family if you say anything. And he's just on the record saying that he's going to go to his grave with the secrets and never say anything. He said it on the record like a few weeks ago. I'm not going to play the recording right now, but I've got it. You guys know I have the receipts. So here is an image that I'm referring to right now by Christy Newton, whatever. And there it is. And there's Jacques Vallée. Jacques Vallée right next to Joe Rogan, actually. So it turns out, as you could expect, let's go full screen here. Jacques Vallée was on Joe Rogan today. Actually today. Now, there's a clip. They actually speak about this dinner at the very beginning of today's podcast episode. And Joe Rogan basically just says, Puthoff blew my mind. Puthoff blew my mind. People in the chat and people on Twitter were asking me, is Joe Rogan trolling me? Is he actually just trolling me at this point? I really do not know. It actually makes me wonder. One of the topics. So I guess my thing to Joe Rogan is this. Whether or not anyone wants to believe me or not, wants to believe the videos are real or not, I don't care. I know it's real. And the reason why I'm doing what I'm doing now, the reason why I'm reviewing stuff like cold fusion is because that's where the science in those videos led me as a person. That's where they led me after I realized those videos were real. And they led me to now my good friend Bob Greenyer and my other friend Michael Perrone, who is with APEC. And basically all these guys do is try to understand how anti-gravity could work and what we would have to do to engineer it. And so that's my goal. The people that I talk to are the people that I think are trying to find the answers, as opposed to people out there just selling books in the same documentary over and over and over again, repeating the same stuff and keep saying that they can't say where the bodies are really buried because that would break all national security. So instead of that, let's just have a productive conversation. So today's special live stream episode is about cold fusion. Now, if you're not familiar at all with cold fusion became popular in 1989. It predates 1989, but that's when it became popular in the public. And it became popular because two guys named Stanley Pons and Martin Fleischman that were at University of Utah? ? Anyway, they were in Utah. And instead of putting their paper out for peer review, they immediately made their results public. This is a big taboo. So what happened? It led to a firestorm, especially when your results are saying that you are producing excess energy. Now, one more thing that I want to frame here for people, and then we're going to open it up and introduce our guests, is what is excess energy? Excess energy is that if you're putting in a certain amount of energy, you should not be getting out of your system more energy than is going into it. And Pons and Fleischman were claiming that they were getting excess energy in the form of heat, in the form of, in some cases, claims of boiling water that shouldn't be boiling. The other huge claim they made is that there was transmutation occurring in their experiment. Transmutation. Like we're on straight up Full Metal Alchemist, the anime at this point, okay? And so the controversy comes now, well, what about the laws of physics? Can those claims be true? They were initially replicated up to 60 times at different labs across the country. 60 times, various aspects of the claims. And then the Department of Energy put together a tribunal with MIT and several other established universities and reviewed the claims of just the positive results that were occurring and systematically debunked the most prominent ones. And so cold fusion lived a short life and then was debunked as fake. But it lives on. Low energy nuclear reactions is one of the forms of quote unquote cold fusion. And we've brought in one of the experts today, Bob Greenyer, experimental engineer, expert on low energy nuclear reactions, and Michael Perrone, who is with APEC and physicist and experimental engineer himself as well. Welcome, guys, both of you to the show today. How are you doing?
Great here. Yeah. Thanks for having me on. Thanks for being willing to talk, Bob, also.
Yeah. Well, thank you guys for being here right away. And so I just want to start with, instead of just digging straight into the hard science, it's going to upset and confuse people. I want to ask you guys a more simple question. And I'm going to start with Michael on this one. Why is fusion important for humanity?
Well, fusion is among the non-exotic sort of technologies, like the stuff that you could do with existing physics. Fusion is the most viable long-term power source for humanity. There's the most of the mass in the universe, or most of the matter that's visible in the universe, is hydrogen, and so you can fuse that into heavier elements, use those heavier elements for things, and then you also get a huge amount of energy when you do that. And so for the near term, that can buy us 20,000 years on Earth before we start worrying about depleting oceans and stuff like that, assuming exponential growth continues, which we don't necessarily need to assume that. And then the solar system's got even way more hydrogen than the oceans do. So it's a fairly acceptable route. Yeah. It is of the non-renewable resources, it's the best one.
And then let me ask a quick follow-up question on that. How is it possible that we can put in less energy into a fusion reaction and get out more energy, which is seemingly the point of how we would produce energy with this reaction?
Well, really, you have the same thing for any process. For example, when you're drilling oil, you use up some amount of energy to get usually as oil. You use up some amount of oil to get more oil, and so if you have a nuclear process that you have to stimulate in order to cause it, you have to apply some input energy in order to get the fusion to occur, and then the fusion reaction has some amount of energy that's based on its physics that's not necessarily as dependent on the input energy. It depends what atoms are there. And then you can extract that, and that contains more energy in it than the energy that you put in.
So we're harvesting the, I don't know, chemical bonds of the atoms or some
nuclear
form of...
nuclear bonds in this case. There's
okay.
The electron shells have chemical states that have energy associated with those, and that's why you burn gasoline and it produces energy for you to use. But the nucleus has energy states just like the electron cloud has energy states associated with it. And so if you have some nucleus that could fuse and then be in a lower overall energy configuration, then just like with burning a normal fuel, you'll get energy out.
Okay. Bob, why is fusion important?
All other energy forms basically come from the sun. So you have solar energy, you have wind caused by basically the sun in some form or other. You have wave. You could argue that fossil fuels are just a store of solar energy. You believe that they all come from a non-abiotic source. And so nuclear energy, whatever nuclear energy you're looking at, is the only real non-solar derived energy, and that we generally have an understanding of. And if you're going to be able to go across the cosmos, as you opened, you can't do that with solar energy because the sun gets further and further away from us. You really have to have another source of energy that is not reliant on the sun or chemical energy. Now, all energy is actually a reduction in the distortion of the physical vacuum. So it doesn't matter whether you're looking at a chemical bond or a nuclear bond, nuclear binding energy, you're basically distorting less of the physical vacuum, and you get energy back from that. And what Michael was talking about is energy returned over energy invested. This is whatever you put in, you get more out than you put in, and therefore you have a net benefit. So, you know, you could argue that a petrol engine or you might call it a gas engine on your side of the pond, it runs, you know, infinitely until it stops. It's like got unlimited energy until it stops. You know, it's when you cut off your sample point, you determine whether it's actually doing anything magical.
Well, I don't think we're going to run out of hydrogen anytime soon. But you know.
And that is a very good point. Yes, I mean, of all the mass in the universe, the hydrogen is the most common baryonic matter. That is like the Mendeleev table. But actually, all the plasma and all of the mass we observe in the universe as planets and suns, that's only 0.4% of the mass. When you add in the non-visible and the black holes, you get to a whole, including what I've just said, a whole 4%. So there's a hell of a lot more energy out there that could potentially be used. That doesn't even necessarily involve what we consider as fusion.
Now, my point of the second follow-up that question from Michael was pretty much, I got the answer that I wanted, which is that with some X amount of input, we can get X plus Y amount of output, or Y, we don't know how much of output that's going to be, but it's not the same amount as the input. And why is that? Isn't that a very unusual thing? Isn't that, explain to me, Bob, why that's not free energy?
Well, it's definitely not free energy in the form of chemical energy because the energy is already locked in the fuel. So if you've got a lump of wood that has so much oxidation potential. That is to say, when you ignite that fuel and it combines with oxygen, which is also part of the fuel in the air and produces, say, carbon dioxide and water, then you are producing you're producing usable energy, but you're not creating energy. You're just using a store of energy.
Yeah. And that's the rub, though, isn't it? For me, as a layman, as somebody who's, not technical, I think this is the gap between what physicists and engineers think of as free energy, which is and versus like what a layman thinks of. For me, any system that's over unity is free energy, but then it's really, like you guys are saying, just a matter of where you draw the boundary on the system at that point.
I mean, the candle looks like over unity all the time it's burning. You put a minimum of effort to start the burning process, and then, wow, it's producing heat and light.
Well, here's the difference, though, is that they're not claiming the efficiency levels that places like the ENG8 lab are with cold fusion, or at least a version of cold fusion, who are claiming 3 to 5 times excess over unity, which is a huge amount on what we would think of in terms of efficiency. So maybe the question really is just efficiency. So what I want to help out for my viewers, though, real quick, is when I'm speaking about free energy, I'm not talking about pulling something out of nothing. Although in a sense I kind of am, because the classical view of physics doesn't really, or discounts the 0-point energy all around us. And I'm saying you can pull energy out of that. But no, instead what I'm saying is that we're borrowing energy, but we're making systems that are so efficient that they're basically perpetual motion for the most part. So for you guys, the next question then, not free energy related, is just fusion related in general. What do you believe is the most, let's say, likely version of a breakthrough for a fusion that we're going to have? Because we have multiple variations on what people are trying to produce fusion out there. So I want to know, what do you think is the most likely to be successful to produce significant over unity process, and why? So let's start with Michael again, I guess.
Sure. So we're going to be getting to exotic vacuum objects and stuff, I'm sure. I'm still not convinced 100% of that, but in terms of the conventional technology, the exciting thing these days is non-steady state processes. So I think there was a company, Helion Energy, and then there's been Lawrenceville Plasma Physics for many years. I actually gave them some tips on what fuels to use and things, and about what they should use after they have their beryllium electron. But that's beside the point. Basically, one is a Z-pinch technology where you have an electric spark, which that could be forming exotic vacuum objects as well. So that's possible if they do it properly. That might happen. And then Helion Energy, they basically, it's like an internal combustion engine for fusion. So they fire together 2 toroids, and there's a non-steady state process where the peak pressure and temperature are sufficient to cause fusion. So this is like a single stroke or dual stroke engine, sort of like you can imagine that these plasma structures are the pistons in the engines, and then you just compress the stuff enough that it fuses. And the nice thing about non-equilibrium fusion, and I saw a couple cool things in the works from Lockheed, actually, where they basically there's I shouldn't go into it too much, I think, but there's improvements to simple magnetic bottle technology with just a pulsed, like now they can get up to 100 Tesla pulsed steady state, not steady state magnet, but a pulsed magnetic field. And so that's plenty for a simple magnetic bottle. And if it's a pulsed thing, you don't necessarily have to worry about the typical stability issues that you encounter with a tokamak, for example, or a stellarator. So in some sense, it drastically simplifies things. And then you're getting the energy out simply from the expansion of the gas, just like a normal combustion engine. So, and then there's obviously it's an electrically charged plasma, so you can also get like Langmuir waves and longitudinal waves in plasmas. and you can harvest energy from those as well. Anyway, that's a little long-winded, but there you go.
No, that's good. I appreciate it. So that one's your favorite, if you had one, or are you just bringing that up as an example? I mean, that was pretty cool. I hadn't seen that before.
I think, and the guys at Quay's Energy also mentioned this. They kind of, a bunch of them left from Commonwealth Fusion Systems because basically they were trying to build tokamaks, and the limiting factor was these things called the plasma diverters. And basically, they were building these plasma diverters out of pure tungsten, and they were evaporating in the vacuum in the tokamak plasmas. They were trying to keep it at steady state, and it was evaporating this plasma diverter component. And so they designed them to sweat lithium to cool it down, to have a coating of liquid lithium on top of the tungsten. It was still evaporating. So it was just too much for those components to handle. So yeah, it's not looking good for tokamaks. I don't know if they can get around that design flaw, that they need that plasma diverter component, and there's just no material with a high enough melting point for it. I mean, maybe they can go to hafnium carbonitride, but then the carbon and the nitrogen evaporate off slowly too. Anyway,
well,
long-winded.
That's a big problem that I kind of want to discuss in a minute. But my bigger question on that, for you on a follow-up is, well, looking at that, is that cold fusion reactor at this point? Like, they're using magnetic fields to squeeze it together. What is really the difference between the different versions of cold fusion? Because the more I'm looking at these newer versions of fusion reactors, I'm like, I don't get the difference between one that's trying to use a magnetic pinch versus temperature based, or if that's the same thing.
So there's something called an overpotential for a chemical reaction or a nuclear reaction. You need to apply, like, there's electrostatic repulsion between the nuclei, and you have to overcome that to bring the nuclei together. The idea with low energy nuclear reactions is if you can catalyze the fusion, if you can bring something in there that shields the charges from each other as they're approaching each other, then you won't have to overcome that large Coulomb barrier, and you can get fusion to happen much more easily. And so Bob will talk about some of this in a minute, I'm sure. But there are conventional way, like using conventional technology, there's ways of doing cold fusion involving muons. So muons are like heavier electrons, basically, and they're a little bit smaller too. So if you take helium-3, for example, deuterium and tritium. Well, actually, not even that, just deuterium. Maybe even just normal hydrogen. I have to check that. But anyway, if you have just hydrogen molecules, and you replace the electrons with muons, they'll be so close together due to the smaller orbital clouds formed by the muons that the nuclei can tunnel into each other and cause fusion at even down to like -40 Celsius.
But the big question is, didn't you just say before that somehow they're like, oh, we found a way to make it more efficient? But yeah, isn't that what cold fusion is doing? Is that they're saying it's not as simple as just heating it up, is that you can make it more efficient with like Z-pinch, with counter-rotating magnetic fields, and isn't that what almost all these new versions of fusion reactors are doing, is like all based on counter-rotating magnetic fields for the most part?
Well, a lot of them have those features in them. If they're using them in that context, I'm sure they can't necessarily talk about it. But
why wouldn't they be able to talk about it?
Oh, I mean,
for like proprietary reasons, or
yeah, either trade secret or ITAR or other regulations.
So let me go to Bob real quick, because he's been waiting very patiently. Unlike Bob, he's just jumping in there. But thank you, Bob. Appreciate it. So, Bob, for you, what do you think the most likely version of a breakthrough for nuclear fusion is, and why? And
well, I guess the best place to start is what is fusion on the sun? Well, that's in debate. Fusion on the sun requires gravity. It doesn't require the way that we claim to be trying to replicate it on Earth, and that is by trying to squeeze it into a small space, or have the fusion fuel in a place and fire high energy lasers at it, or electrostatically confining it in a fuser, or like a Farnsworth fuser, or smashing it together by raising the temperature. None of these things are what is going on in the sun. So straight up, fusion, as we attempt to do it on Earth, is a flat out lie. And so because we don't have the gravity, and then we can get into what is the gravity, but that's another story. So what do we know works? Well, we know a fusion bomb works. We know that because it has been done. And the largest bomb that was ever detonated by the US was Castle Bravo. And Castle Bravo was what's called a dry fuel bomb. It didn't have any cryogenic tritium and deuterium in there. It had lithium deuteride, and it was natural, or mostly natural. It was slightly enriched with lithium-6 because they thought that that was the active isotope of lithium, and deuterium. And they would have a plutonium trigger, and that they would have natural uranium. So it had natural uranium, might as well have been natural tritium, some deuterium, natural, might as well have been natural lithium, natural deuterium, no tritium. The tritium was bred, and it was actually nearly 49% aluminium. The box of the bomb and the number of atoms, it was 49%. So with uranium and the natural uranium, not highly enriched uranium, this was just straight out of the ground, just uranium isotopes, 238, 235. They made the biggest bomb ever. Now, they put that down to the fact that lithium-7 played a role. I don't agree that that was the whole story. I think aluminium played a huge role. And the reason I say that is because it's the most affected material in the Hutchison effect. It's the most affected material in our ultra experiments. It's a fuel that seems to fuse very regularly. I recommended this to the expert in ball lightning, Dr. George Eagley, and that is part of ENG-8's electricity producing over unity reactor. And it is the key element used by Tesla in his shadowgraph tubes, as being replicated by the work of Griffin Brock. Now, this brings me to what, therefore, is the most advantageous system I can imagine. Well, if we look at Avi Loeb's attempts to recover magnetic particles from the Pacific, we know that's in the fallout zone of Castle Bravo and other Pacific tests. He found iron-rich spheres which were comprised and contained beryllium, lanthanum, and uranium. These are all components used in fusion bombs in those tests. I believe that his iron-rich spheres, because iron 227 aluminiums fused, that is real fusion, that seems to happen in a lot of LENR experiments, fuses to iron, the most commonly found element in LENR experiments. Not helium, not other things you might think would be fusing. It seems to be iron, and two aluminium 27s fuse to iron. So you actually get the witness material of the fusion energy that may have been a big cause of the fusion energy in the Castle Bravo. So my preferred technology would include aluminium and lithium and hydrogen and one other element, carbon.
Where's Ashton?
We've been abandoned.
Whoa, okay, okay. Yeah, I was listening to that whole time. So that was amazing. The sun, plasma. So no, I'm just kidding. The sun is acting like a plasma reactor. So basically, when we're trying to make fusion reactor, we're trying to make it act like the sun.
No, that's a lie. It's a flat out lie that they've spent billions and billions keeping taxpayers on the hook for. We are not ever replicating what the sun does because we do not have the gravity. We try and overcome the gravity issue by having a increased temperature, that is kinetic energy, essentially, or either confining it in some way. But it's just a flat lie, and they know it's a lie.
Yeah, but so here's the thing. And so you're bringing up a good point. If we don't really know how the sun works, then how can we be successful with fusion? But the other point is, if we're just going to discount gravity as an option right away, then yeah, we're kind of selling ourselves short, because it's kind of a big factor on what the sun's doing is the gravity part of it.
The question is, can you make a highly localized point gravity?
Yeah, I would argue, and I do pretty much every day, that you can do that, that you would be able to do that. I would even take it a step further, because I don't know, I didn't hear your response, but tell me how close I am, that what if cavitation is doing that? What if it's some form of negative energy pressure? What if gravity is just a pressure and all we then need is a negative pressure to counteract it? Then could we create like a little puncher shrimp cavitation bubble, but somehow cause that to cause, a collapse of matter or energy down and create fusion? Is that feasible?
Well, I mean, if I can have a crack at that, if you look at John Archibald Wheeler, that is the tutor of Feynman and the person that was involved in the process of making that bomb, the Castle Bravo bomb and the Manhattan Project, he published a paper called Geons in 1954. And he argued that all matter were standing waves of light, and that they were bound together in these standing wave tori with a gravitational azimuth. And if that is what matter is at its most fundamental level, then you have a means by creating not normal vacuum objects, but exotic vacuum objects that are fractally self-similar to those substructures that he quotes, which are the basis for everything from the microcosmos, the subatomic, all the way through to the black holes and galaxies. And he invented the term black hole and wormhole, so he should know.
Wheeler did?
Yeah.
I feel like I don't give him enough credit. Wait, so Wheeler helped build that bomb as well?
Yes.
Wow, and he's also one of the two that claimed that there was enough energy in just this coffee cup, Forbes coffee cup merchandise, by the way, guys.
He was one of the two that come up with it. Yeah,
enough.
That's a nice cup.
All their notions. So it seems interesting to me that the guy that developed the biggest fusion bomb, that has said that all matter is just energy trapped in a resonance. He's not the only one to say that, and I completely agree. This is the guy also came up with the term black hole. And for some reason, we're just discounting that maybe there's like some excess energy possible somewhere.
Well, so I should mention here, this is not non-standard physics yet. Like the nonlinear sigma model is basically used to describe Yang-Mills theory, roughly speaking. And that model describes many of the particles as solid tonic objects. So you have a nonlinear equation describing the behavior of these objects, and it's that nonlinear equation allows the energy to stay localized. And so that's the standard model still. That's not anything like how should I put it? If you look at vacuum noise in terms of a Minkowski space-time diagram. Mind pulling up a Minkowski diagram?
Yeah.
Yeah. That'll be helpful as a teaching tool here. So the question here is, what do virtual particles look like when you describe them in Minkowski space-time? Using in a relativistic context, what does a quantum fluctuation look like? And so you'll see basically
that's what you want, right?
Yeah. So you've got some. Yeah. So what does a virtual particle look like in this context? So quickly to explain, you have space in the flat plane here. You have two dimensions of space, one dimension of time. This is a reduced dimensional explanation just to kind of get the idea across. But basically, if you have by convention 45 degrees on the side there, well, it's good to keep the image up. If you have like 45 degrees on the side there as your speed of light, because the vertical axis is time, so the speed of light is going to be line through there at 45 degrees or whatever angle you choose, really, but the convention is 45 degrees. Anyway, this is a relativistic concept. What happens when you take quantum mechanics and you try to describe it in terms of this relativistic concept? Well, a virtual particle, you'll have a virtual particle pair that appears at one instant in time, and the particles drift apart and do whatever they do, and then they come back together at some later time. So you have this volume of space-time, which is carved out by, you have a cone going forward in time and a cone going backward in time. So there's volume of space-time that's carved out by this virtual process. And so as you increase the energy density in a localized region, then there's this time energy uncertainty in quantum mechanics. You can look it up, but basically the more energy is in a location, the longer a virtual particle can exist.
Okay.
And so these space-time volumes increase in size and they become more frequent as well. So eventually these virtual particles will overlap, these volumes will overlap. And when that happens, you get not a spontaneous symmetry breaking of the vacuum, but an expected phase change of the vacuum, which should be, I need to go through the calculations a little more and make sure, but it should be equivalent to Yang-Mills theory. So what we're saying here, roughly speaking, is that this expected phase change adds a nonlinear term to the equations, which allows the solitonic behavior. But sorry, that's a bit of
So my question is really this: why do we need new physics at all? I don't understand why we need new physics.
Well, we should be extending the existing physics and showing how it fits within a larger framework that explains these new experiments, of which there are many at this point.
I don't think we need anything new.
Go ahead, Bob.
I do think we need things that are not recognized.
Yeah. See, that's my point too, is that, just real quick, and I'll let you jump on it as well, is that I think that we really don't need new physics. One of the things that I learned listening to Avi Loeb and talking to Avi Loeb, who's, Harvard physicist, mainstream as it gets, but also thinks outside the box, is that the idea of adding 0 point energy, or this idea of this excess energy that's around this medium, actually doesn't seem to change any of the existing laws of physics. Just adds, looks at it through a new lens, honestly. And even when I read Puthoff and all his papers about 0 point energy, using the ether, he's just using all standard physics, all standard general relativity, Einstein's equations, Minkowski space-time.
Just like Sal Pais was saying, it's a new perspective on old physics.
Yeah, and Dave Rossi says that as well. And so that's where I think, when I look at this, that's why I asked you the question about, is this cold fusion, or are we just getting to the point now where lines are just blurred, where even classical view of physics is kind of figuring out, just through process of elimination and working through the fusion over 50 years, that it's just inching closer and closer towards, we need another way to do it other than just straight up temperature, if that's pinching or whatever the other mechanisms are, muon infused, catalyzed fusion or what have you.
Well, I think we should start with the beginning, and this is Ruby Carrot's book on cold fusion. It's very, very thin. It's done as a little comic book. But the most interesting thing, I think, in here is what is generally referred to in the field of cold fusion as the Pons and Fleischman singularity. So this was about 2 years before Pons and Fleischman were forced by Stephen E. Jones to release their data early because there was patent issues and this, that, and the other, and Brigham Young University wanted to get a head start to put their flag in the ground, and this actually scared them. And it was, as I understand it, about a CC. It says one morning in 1985. So this is actually in 3 years before, or 4 years almost before 1989. So it's relatively early in their experiments. They had, as I understand, it was about a 1 cc of palladium loading for a number of weeks in the electrostatic setup, such that the deuterium was going into the palladium, which was established, I think, in 1870s as being the metal that loaded the most hydrogen. And essentially, someone turned down the electrostatic pressure, which would in theory let some of the gas come out. And according to various people's theories, including Ken Shoulders, that would cause cracks, which would cause charge clusters to form. That aside, they don't know what happened. What they did is imaged in this little picture here, and it's easier for me to say. It boiled off all the water. It went through the glass, through the worktop, and into the floor. And by some accounts, it's about a fist-sized hole in the concrete was removed out of the concrete in the floor. And they realized whatever this was, it was not fusion. It was way, way beyond fusion. And there was extremely fine particles of dust completely suspended in the air such that they weren't able to settle out.
Well, let me ask you a follow-up on this. This is actually great. We're having a good discussion here. Would you think Pons and Fleischman's experiment was legit? And what do you think they really discovered? Like, was their experiment the big discoveries they found? Did this exact experiment was something, or did they find some other property of nature that people didn't?
Well, I mean, they were investigating things that had been done in secret in Russia in the 1950s. And I think there were Wendt and Irion in 1920s or stuff that did some similar experiments. But if you go and look at in fusion technology, infinite energy, in 1996, there's an interview between Martin Fleischman and Christopher P. Tinsley. And they're talking about what they were actually investigating at the time. They were investigating the behavior of electrons in metal. That's one thing. They were investigating this heat production process. They were investigating, it would appear, because there's something cut out of the conversation, gravity, and one other thing. He was confused by vacuum tubes. He was confused, and I think that might have come from maybe the work of Henry Murray.
So what do you think? You think they were legit, though, or
they were totally legit. They spent their own money to do this research. A lot of it. They worked for 5 years spending their own money. You don't do that unless, one, you've got a good reason to think it's going to do something interesting, and two, coming out with that, you didn't think you could stand behind it, and they did stand behind it. And contrary to popular belief, they were forced out of America, and they went and continued with their work in France under the sponsorship of Toyota for 5 years.
That's very interesting, because Jean-Louis Naudin had a bunch of cold fusion stuff on his page, and he was basically checking all of these exotic technologies for the French government, if I understand correctly, back in the day. So from my perspective, I know Jeremy Rees, he went for many years to the Cold Fusion Conference at MIT. And basically, for many years, they struggled to get it to be reproducible. And like towards the end, I think 2014 or I don't know, one of the more recent ones, they basically got it down to you need about 95% deuterium loading in the palladium. If you have too much or too little.
That wasn't recent. That's 3 decades ago.
Oh, yeah, well. but basically, since Pons and Fleischman, it has been made into a repeatable experiment, is what I'm trying to say.
You can do these kind of low-energy nuclear reaction processes, whatever they are, repeatedly as a 3-year-old in 7 minutes. There are many ways to do this transmutation process. One who had success early on was Dr. Matsumoto. Sadly, he's left us. This is his book from 1990. And he shows the key kind of structures in here, like what he calls cold fusion stars. And these were published in Fusion Technology. So these things.
Well, let me jump in real quick, and we can say that more, because I want to kind of address that point. There is this kind of disconnect where one side says, well, it's not reproducible, and the other side says, well, it's been reproduced all the time, we're still reproducing it now. And I guess in my mind, I'm reconciling that going, well, is it the issue where, because I mean, we are doing all these different forms of fusion research, and some of them are claiming to be somewhat successful, not really having any commercial products though. So I guess the question is, is it reproducible or not? When we're talking about reproducible, are we just talking about Pons and Fleischman's version?
I would suggest you look at who's spending what. The entire research fraternity in Japan, who, bearing in mind they don't have any real energy natural resources, are full on behind this. And you just have to look at what's happening this year. I've just been informed this afternoon that the US will spend 300 million plus another 60 million on this space this year.
That's very exciting.
Yes, it is. And that came out of the European work, which partly came out of our open projects work, because we replicated.
Let me jump in and ask that and bounce it back to Michael too then. So that, Michael, I mean, if it's not reproducible or no one's reproducing, then why are we spending so much money on it? And is it possible that it really was actually reproducible?
Well, no, I did say it was reproducible.
Oh, okay, sorry.
They had trouble in the early days, but they more or less figured it out during the course of the MIT conferences, is what I mentioned.
So is it still the same experiment though? Because which one is the one that's
there are a lot of experiments, and
exactly. What are they showing? What are they actually showing? Go ahead.
Titanium deuteride works. There's a fully, as I understand, a fully conventional technology using erbium deuteride that and bremsstrahlung radiation at NASA. They did that particular experiment.
I don't believe those results. Sorry, Larry Forsley.
Oh, who's that? What?
I don't believe their results. Sorry, Larry Forsley.
You don't believe Larry Forsley's results?
No, because they don't detect neutrons in the same way that I believe you need to, because the same process they're doing. So they're taking accelerator and they're firing into a conversion target, producing gamma rays, and they're looking at, I think it's Oppenheimer-Phillips reactions or something going on. But what they're doing to produce those gamma rays is exactly and precisely the same thing that is published by Moscow Nuclear Physics Institute under Bogdanovich et al., where they produce these structures which are magnetic monopoles. And the magnetic monopoles are what appear to do the work. And the magnetic monopoles are clusters of charge.
I think you're a little quick to jump to it must
be...
No,
because they do not use, they do not use gold activation or indium activation in their work. All of their devices are electronic. And even if they are neutron tubes have been shown to produce fake neutrons. And you have to bias them in a different way. So the challenge is, I don't think that work is going to ever come out in a useful way, because it's designed, even if it does work in the way that they're saying, it's designed for producing energy on a spaceship, not for the general you and I.
The signal to noise ratio in their measurement was reasonable. I think they did what they did, and
they're very good at writing papers.
No, if you look at what they've done, the erbium. The density of erbium deuteride, that's about as dense as you can get hydrogen.
I'm not saying that fusion doesn't occur. I'm just saying it doesn't occur the way they're saying it.
It's denser than metallic hydrogen. You're getting those hydrogen nuclei really close together. The closer together they get, the lower the overpotential is when you try to overcome the Coulomb barrier. So
I know that one of 70 theories. Yes, I know that one of 70 theories.
Question is, okay, so we're trying to overcome the Coulomb barrier, the repulsion, electric repulsion or electrostatic repulsion, I suppose. And
Ashton, that's what we're told we need to be overcoming.
Okay. Just that, you're right. That's fine. You can address the whatever underlying assumptions when it's your turn. So yes, we're told that we are trying to overcome this Coulomb barrier, and this is going to be important too when we talk about EVOs, so what they're trying to do in these various forms of Pons and Fleischman or variants of cold fusion is find ways to reduce that Coulomb barrier. So I think what Michael just said is this very heavy hydrogen is a good way, potentially candidate, to begin to accomplish.
So I can give you one example of that. That is the H minus particle in Francesco Piantelli's system. So Francesco Piantelli, in August 1989, after Pons and Fleischman, he was doing a biology experiment. Cut a long story short, he has a theory where you get H minus, which is an H with 2 electrons, forming, and it acts like a muon, and it goes in and it does one or two things. It either spits the proton back out, or it basically, for nickel 62 and 64, if you calculate the radius that it would be orbiting at, it's already inside the nucleus, and so that's why the nuclear reaction occurs, and you get copper forming. That's a heavy quasi-particle doing the job. There are many other particles discussed in these areas, but they're kind of like flights of mind, and they don't really have any meat and potatoes, as it were, on the actual experimental observation. In the case of Francesco Piantelli, he actually observed in a cloud chamber protons, and you can tell the proton under a magnetic field in a cloud chamber because of the way it spins, it curls rather, and how far it goes and what it interacts with. I think it's something like 5.7 MeV. He calculated these protons, and he actually had an event in his lab where he produced fantastic numbers of neutrons, which were determined by gold foil activation, not by electronics, which gets fooled by the quasi-neutrons. And he calculated that was an interaction between these protons that his process was producing and the vanadium 50 in the steel that he was using in his reactor. Now, what we do know is from all the way back to Langmuir in the 1910s, when he was producing tungsten filament light bulbs, for some reason, he saw a production of 7,000 times the volume in some gas of the volume of his tungsten filament. He couldn't work out where it was coming from. Now you fast forward to Mizuno, a famous Japanese researcher. He's still with us, thankfully. And he did research. He found the production of hydrogen. Other people have found the production of hydrogen. And so if you're producing hydrogen, that might explain some of these observations from other elements.
If I can just make an observation here. Mizuno's experiment involved thermal electrolysis. Well, that's a fair point. He did. I assume we're talking about the electrolysis experiment, right?
He did one with tungsten. It produced a COP of 800.
Yeah, I've replicated that experiment with the Geiger counter, in fact, and I've seen this at least a slight increase in neutrons. It wasn't in like what you would expect from standard fusion, but then again, with these exotic vacuum object fusions, maybe you don't get what the typical behavior is. Well, we know that, and there are many explanations potentially for that. But yeah, it's...
We can't hear you, Ashton.
So you recreated the experiment with the Geiger counter, and you saw some excess radiation?
Yeah, maybe twice, three times background. It varied a lot. I did not have the optimal setup for the Mizuno experiment. But the thing with the Mizuno experiment...
Hold on, you said Geiger counter and neutrons. I don't know whether those two things go together.
It's a rough estimate. The
Geiger counter isn't measuring neutrons.
It's just measuring whatever.
No, it's not measuring whatever. A neutron detector measures neutrons.
Yeah,
a helium-3 or a boron-10.
Okay, so it's probably... Well, no, that particular type that I had was an old relic from the World War II era. So,
but what was it?
It had uranium. It had uranium. Well, it could be alpha particles then, right? So,
if it's a Geiger counter, it can measure alpha, beta, gamma, and it can measure that depending on what you put in front of it.
Right. In any case, I measured some stuff that was slightly over background, which could have been other processes after.
It could have been your background.
Okay, well, let's get to the point.
My point being is I saw some interesting results with the Mizuno-like experiment, but the excess hydrogen, you're electrolyzing water, and not only are you electrolyzing water, but it's less well known that you can water can undergo thermolysis at high temperatures. So you can, if you get the temperature high.
I think he knew that, and I think he actually discusses it in his papers.
Yeah, he does. I'm just explaining this for the audience.
Yeah.
But as you increase the temperature of your electrodes, electrolysis becomes more efficient. So up to the point where you can get what looks like over 100% electrical efficiency, but you're actually using endothermically some of the heat from the electrode.
And how does the heat in the electrode get there? How does the heat in the electrode get there?
Well, interesting point. Yeah, good point.
It either comes from the electricity or it comes from the overunity produced in the fusion or fission processes. The reality is, since the beginning, it doesn't matter whether you look at this guy, Ken Shoulders, whoever you're looking at, you get both fusion and fission and other things going on. It's not just about fusion. It shouldn't have been called cold fusion for a long time, and that's why it's been called low energy nuclear reactions.
Wow.
And in fact, they called it cold transmutation of nuclei and ball lightning in Russia, because it is all of the above, including synthesis and desynthesis of matter. And when you're talking about synthesis of matter, you're capturing some energy from somewhere, be that light, phonons, vibration, or actual some other form of dark matter and or dark energy, and you are cohering that into new matter when you are synthesizing matter. And that appears to be some of the things that is going on. It's far more interesting. And so I made the mistake. Sorry.
One at a time. Just want to mention before we get too far ahead, I just want to mention, like, one of the main difficulties with the existing scientific community in terms of getting them to look at this or understand what's really going on here is you have condensed matter physics, which generally focuses kind of on the chemistry and the bulk material behavior. Occasionally they'll care about boundary conditions, cracks in materials, microstructures, but it's not a focus really of that field unless you're doing catalysis. The standard
absolutely every single way to promote this process.
But then like most people are trained in either condensed matter or nuclear physics. You need people who can speak the language of both condensed matter physics and nuclear physics to bridge that gap, and that's a challenge. Those are two of the most complicated fields we have right now.
Yeah, so let me just break this down, because it seems like we kind of got to the point now where we finally got down to an experiment that shows some anomalous results, and we kind of both agree that it does, and got to the point where we can't fully explain with classical view how that could be, assuming that the results are accurate. So then the question is,
it doesn't stand in isolation, though.
No, that's fine. That's fine.
Specifically,
we're assuming that it's real for now, so hang with me.
No, but I mean, it wasn't just Mizuno. I'm sorry, David Hudson observed the same thing. Sure. We observed the same thing, and before that, we had Orion Energy, which was formerly called the Sapphire Project, observed the same thing.
So
it's
where
tungsten.
Is the coefficient of performance coming from? That's my
fissioning
question.
Of tungsten.
Do you believe that free energy is possible?
The release of energy from a triggering catalytic process, which is far and above the input energy you put in, and far, far beyond chemical, is possible.
Yeah, that's free. To me, that's free energy. Because again, what did we say before? Michael was saying, well, we have some fixed input amount, and we're going to trigger a nuclear or a fission or fusion or both reaction, and that's going to release more energy than that fixed input amount.
Well, there's some chemistry term called Gibbs free energy related to this, but it's not quite free energy in the sense that, like, you have an arbitrarily large amount of energy that's as big as you want it to be. There's also something called non-equilibrium steady state processes, or non-equilibrium statistical mechanics, and there's a whole other field of study of basically recycling thermal energy from the vacuum. And you saw this with the orbs. They cool down instead of heating up. If you have something that's expending megawatts of power or something, it's gonna have a heat signature. But and anyway, that's a whole other topic with a whole other conversation.
It kind of gets to this topic because that's what I think we're steering toward. Something called EVOs, exotic vacuum objects, which is like what Bob is saying here in that experiment. If it's possible that we could have some low energy cause reaction that causes both fission and fusion, I mean, that seems like we just found the tools to engineer free energy just straight out of the vacuum. And then when I'm calling it free energy, I'm just being coy, because really what it is just coefficient of performance greater than 1. We found some tool that can interact and produce energy at a very efficient rate.
Well, it's a little bit more than that even. It's you're breaking down the wall between chemistry and nuclear science. These sorts of effects, and Bob can get into the details. He's the guy with all the years of experience there. But these sort of effects allow you to access nuclear behaviors way more easily than was conventionally assumed. Like back long ago when they were saying, "Oh, we could transmute lead into gold." Well, theoretically, you could. I mean, lead has I think lead is further than gold on the periodic table, right? So if you could break that nucleus up, maybe you could get a lower energy state. It really depends on which isotope of gold you're going for, and
it depends which way you're looking at it. So when we built the Parkhomov reaction tables in 2019 or 8, I don't even know when. It's a long time ago now, which are freely available to look at on physviz.com or LENR. It's nanosoft.co.nz. You can go in there and you can type in the elements that they used, calcium and potassium, as one of the inputs on the left-hand side of the equation, and you can put in lead, mercury, or bismuth. They didn't use thallium, which is good because it's super toxic. Those are the elements that are most likely to produce a fair proportion, more than any other element combination, of gold. So I was able, the first thing I did, because everyone asked me, "Oh, you do LENR, can you make gold?" It's like, oh, okay. So I just dealt that straight off. Yeah.
That's all hard.
And it took me 50 seconds to produce 5,000 years of 5,000 years worth of alchemy practical experiments correct. The elements that they were using were the best elements to use to synthesize gold. And it's not just a fission, it's a nucleon exchange reaction.
Interesting.
So here's the thing, because this is what I think I was trying to get you guys to say earlier, because we're not picking up on what I was putting out there in terms of what is it that my opinion, when as an outside person saw all these different versions of this similar experiment, and then I saw Ken Shoulders and EVOs, which is just plasma. I'm sitting there going, well, maybe there's this underlying, they found out something underlying about it. Like, how do we actually just like interact with space, the Minkowski space-time directly at that quantum level? Maybe that's the interaction there. And
well,
so I guess just real quick, what I want to say though is that why can we do these transmutations at low energy? And then, I guess for Michael, or maybe for both of you, then what makes you skeptical from the physics perspective of why we can do that? If that's what go ahead.
Can I go ahead?
Yeah, sir. Go.
I would say very simply that most ordinarily stable atoms and whatever. Let's break it down a little bit more. A stable electron, a stable proton, and a stable neutrino, and their anti-particles. They are stable in our vacuum state. If you are able to change the vacuum state, all of the rules change. A proton is able to be stable for all of time, but if you change the vacuum state, then all bets are off as to what you can do. You rewrite the rule book, and that is what an EVO does.
Yeah, they were talking about this with the thunderstorm generator, which I'm a little skeptical of as well. And then the there may be something there, but so it
definitely has the signatures.
Yeah. So where was I? I guess I shouldn't say I'm skeptical per se of EVOs as a concept. I more am critical of Bob's dialectical approach, given that he privately to me has said he wishes to not necessarily convince all the people, but rather to get the technology as far as he can. And that's fine. I mean, back in the day when people were engineering steam engines, the equations for steam engines weren't fully figured out at the time, but they were perfectly useful and people were using them. And so that's a fine approach. It's just the dialectical approach. I mean, the dialectical process, assuming everything's in EVO, and
sorry, are you speaking for me?
Sorry, I
think he's just giving his criticisms right now.
But so just
it's best I speak for myself, if that's okay.
Well, yeah,
I just worry. I just worry that it will drive away competent engineers who can help you to make that steam engine work, so to speak. That's that's where my criticism lies. Not really with the EVO.
Well, on the thunderstorm generator, it has the telltale signatures of this process. They were predicted based on a visual video file that I was sent, because we'd seen the same thing in our experiments, and that would produce the same things that Matsumoto saw, that we replicated before we even know Matsumoto had done it. Now, with regard to that kind of technology, you just have to go and look at patent number 4397268, August 9th, 1983, awarded, but applied for on September 24th, 1981. Which is a intake air moisturizer by Charles L. Brown, which produced similar effects, but was basically banned. He was a military guy, and he was just injecting moisture into the engine. So there's real reasons why that could work, just as a system by which it creates more efficiency. And that's all that Malcolm is claiming, although he seems to observe oxygen coming out, and this was something that was claimed by Paul Pantone, who also claimed nuclear transmutations. And what is going on in both of those systems? Both of those systems have extreme multi-axis hydrodynamic shear. Extreme multi-axis hydrodynamic shear. And here's the thing. There's only one structure in nature that allows for negentropy, and that is the vortex. That is the vortex. And according to Maxwell, the ether is made up of a lot of vortices. And if you can make a vortex which is able to cohere something, which is a condensate, and spin it really, really, really fast, you may be able to disrupt matter in ways that you ordinarily wouldn't expect. And
you know why it's interesting, real quick, if I can jump in?
Yeah, go for
because
it.
The reason why it's interesting that spin or vortex might be relevant is that when we look at electrons or particles that are quantized, we look at it from a quantum spin perspective, because precession spin prevents something from tipping over. It prevents from being moved out of its axis, moved out of its orientation. So it almost does seem like if there was going to be some law of the universe that we see scaled up, scale invariant, that seems like one of them.
Now, if you imagine you have your normal state of chaos going on, where you've got like bits of spin pointing in every direction. When you start, one thing that people might understand something about is aligning spins producing a very strong magnet. And then people start to get confused. What is the thing that's coming out of the magnet, right?
Yeah.
There's definitely something there. It's going across space. I don't see things flowing around, but there must be. Or is there? I don't know, because I can't feel it. I don't feel a wind.
That's the point of the ether as well, right? Is that people would say, in Maxwell and many other people believe that there was an ether, especially the people that started. But the problem is, we couldn't. Well, where is it? We can't feel it. But then you go, well, that's also true of magnetism. But you can feel when it pushes you. There's something there, but there's nothing pushing out at you. So how's that working? So I guess is the vortex? Is that the answer? Is that the reason why Salvatore Pais's magnetically confined fusion reaction uses, and many of these others use counter-rotating, or I can't do it.
I can tell you that even in his wildest dreams, if he did not spin those things, nothing would happen. The British Railways 1971 UFO patent would not work without the big spinning homopolar generator, just like the ARV, the Alien Reproduction Vehicle. If you didn't have those spinning things, the thing would not work. Now, what do those spinning things do? Well, they produce these weird little clusters. It spits them out.
So you think that was Ken Shoulders using that as well?
Ken Shoulders if I can add something here to connect this to existing physics, so that we don't scare away quite as many engineers. If you have superfluid helium, well, if you have a normal fluid, what happens when you spin the container it's in? Well, relative to the container, the fluid starts spinning. There's some distance in there. There's like a viscosity and stuff. But if you have a superfluid, there's no viscosity. So what happens? Well, spin is quantized. And so when you start spinning the superfluid, it develops vorticity vertically away. So, and also this vorticity, it dies off with distance relative to the center. So if you
hold on, can I just say that when you spin a superfluid like liquid helium, like Piotr Kapitsa did and got the Nobel Prize for, you end up with little vortices within the overall Petri dish, let's say.
Yeah, exactly. So
and we see that in our experiments. We see matter torn apart by these little vortices.
There's just to tie it to conventional physics, if you just go outside and you spin your arms around, you feel a force pulling your arms out. Centrifugal force, right? Well, when you're in the spinning reference frame, if the vacuum is a superfluid and it starts spinning relative to you because you're spinning, then you will have along the spin axis a gradient of these vortices. And this creates, roughly speaking, what is like a gravitational field. So there's some equivalence here with conservation of momentum in this case, and angular momentum perhaps, or but this outward force is like a gravitational force in its nature, and these vortices, these flux lines in the superfluid, if assuming a superfluid model of the ether or vacuum or whatever you want to call it, they're quantized and on a very small scale. They can interact with particles. Anyway, I just wanted to connect it to known physics so that we don't scare away so many engineers.
Yeah, no, that's cool, because I do think that the ether is probably quantized like that and should be thought of as a superfluid. So what we're talking about too
what am I saying that's not known physics?
No, that's a big point that we have to keep bringing up, though, is that we're talking about stuff that is, I keep bringing it up, is that this is just mostly known physics, but it's just not very well understood.
Like the Aharonov bomb effect. The Aharonov bomb effect is a known piece of physics that most people do not know. And the Aharonov bomb effect has been calculated in 1998 by Afanasyev and Dubovik at Dubna to occur in the center of these fractal toroidal solitons, these exotic vacuum objects. And so you have both the thing that can cohere matter into a phase singularity spin and cause, once it's cohered, an unlimited amount of matter to go into a very small point.
Right. So I want to add something to that. And you'll be happy to hear about this, Bob. I don't know if you had considered it, but with these fractal toroidal geometries, well, I mean, you know about Masahiro Daibo's work, I assume, right?
I'm not great necessarily with names unless I've personally met them.
They used a zero inductance thing where you have a wire going straight and then you had a wire coiled back around it to the original point. And they were showing that sort of wire, it will kind of like a caduceus coil as well. That sort of wire was able to pick up a voltage, it induced voltage from a change in the magnetic vector potential alone.
Okay.
And so anyway, this is important for these fractal toroidal structures, because what Masahiro Daibo demonstrates is that, okay, you have this magnetic induction term from the magnetic field. You also have an induction term associated with the divergence of the magnetic vector potential, which, or not even, just a fluctuation of the magnetic vector potential over time, because of the Aharonov-Bohm effect. The Aharonov-Bohm effect still happens in conductive media, and so it will still cause charge separation and basically diffraction of charge of the electrons, really, and possibly other matter, but usually when we're talking Aharonov-Bohm, we're talking electron diffraction. But if you have electron diffraction in a conductive medium, and that medium is coiled in a way where all the peaks line up, then you can get induction from just a magnetic vector potential field that's varying in time.
I think the bit that's important to me is, can you take two different de Broglie wavelengths. That's the wave description of a piece of matter, and get them to the same kinetic energy and bring them in phase. And this can do that. And that's the only thing that I'm interested in. Can it do that? Yes. Can it do that? No. Yes,
well,
it can do that.
Interested in connecting it to the known physics.
No, I mean from the point of view of trying to get a point in which coherent matter can aggregate to
Bob,
go beyond.
Is that a coherent matter wave? Is that what you're talking about?
It leads to the coherent matter wave. And when the overall coherent matter breaks, the coherent matter wave comes out, and we videoed these things.
So here's a question I have about coherent matter, actually. Something I don't fully understand. So basically, you have fermions and you have bosons.
Yeah, you make a fermion first.
Bosons can go to the same state, and fermions have to be in different states. There's this degeneracy pressure. I think this is the key point. Do these exotic vacuum objects somehow remove the degeneracy pressure and convert?
It's not a singularity
behavior. Convert the fermions into bosons so that they can overlap.
It does convert fermions into bosons. Yes, you can look at Wisniewski's paper from 2008.
That explains it, because now you can take electrons and they can all fall to the same quantum state, and you can get these extreme charges.
Yes,
and that's why.
Yes.
Okay.
So let me hold on, because I want to help our audience understand what you guys just said, because many people, once you said fermions, bosons, they got no idea what you're talking about. Guys, fermions, we're talking about this mug here. Why does my hand not go through the mug? Because the electrons are bouncing off of it, because the electrons can't collapse onto a single point. They have to obey the Pauli exclusion principle. They can't obey the same location and the same place in space and time at the same time. Bosons can. So what's an example of a boson? A laser. A laser has photons overlapping over top of each other. So what Bob is saying is that we can convert something that's like this down onto a single quantum point. And then what Michael is saying is, well, holy shit, well then, however much charge the original had, it should now be amplified down onto that single point. Well, however much was there before, right, is being compressed onto that quantum.
No, not the charge, but the magnetic moment.
Look at that. Wow, we are figuring out some science here. Now, that's a great thought, and I want to do more stuff like that. So one thing that I want to ask is that, Bob, you were saying earlier, well, the neutrinos or particles or whatever, they don't obey the same laws if you break down, if the vacuum space-time breaks down or what have you. When you were saying that, man, that makes me think of Hal Puthoff's space-time metric engineering paper, changing the refractive index of space-time using electromagnetism, which is also what Salvatore Pais's U.S. Navy patent, high energy electromagnetic field generator, is literally stated to intend to do.
I should also mention Amy Eskridge on multiple occasions brought up gravitational chemistry, that her father or something was, or some person she knew.
You know, her dad worked on like plasma thrusters and like.
Well, I don't know. I just recalled that she mentioned this gravitational chemistry thing. And so under different vacuum conditions, chemistry also proceeds differently. I know.
Okay, next thing I want to ask you real quick, let me just, because the last thing I was going to say on that was that Ken Shoulders, I want to hear your explanation for this. When he made his EVOs, what he noticed is that he called them charge clusters. The electrons were clustering together. Hold on, let me just finish. Let me finish, Bob. Please, let me finish. So the electrons were clustering together, but they should be repelling one another. So is this the same as overcoming the Coulomb barrier? What's the connection, or is there one? And what is the explanation for that behavior if it's real? Whoever wants to go first.
Yes. So they become, one explanation for it is a property known of these toroidal plasmatoroids. Plasmatoroids abbreviated to plasmoids, and you then have a situation where they're fractal and they produce this Aharonov-Bohm effect. The Aharonov-Bohm effect is able to pull in the electrons into this bit where they go up to the center of the vortex and then they get stuck there. It's not a point. It's not a zero-dimensional point. It actually, the degeneracy pressure prevents them from no space. They actually occupy a finite space. And then you get these fermions being converted into bosons. And that was done in a Dirac monopole compliant way. It's a topological monopole by Wisniewski in 2008. And that paper is quoted by at the Moscow Nuclear Physics Institute in Bogdanovich et al., where they saw these plasma toroids moving around on metal for 2 days. So they can go in there. Now, when you occupy the same state, you know, that how many electrons have you actually really got? And then the other thing is where is the charge actually coming from? It's not just that they might be going in there, they might be going into the fractal clusters. And when you've got things bound up into these structures, they appear to lose their charge. And not only that, if you have a normal electron, it has its charge. But if you have these clusters, they end up having electromagnetic waves that they produce, but they cancel at what's called a non-radiating boundary. And outside that, they don't express any of their charge. And so you actually create like a normal vacuum object, but it's an exotic vacuum object. But because of its structure, it cancels its own electromagnetic waves. And so there's no expression of charge outside of a particular space.
Wow. We're reaching the edge of my knowledge. I'm not sure how that happens yet.
Yeah, how would it? Okay, well, yeah. Instead of going too much into that,
it was originally discovered by Yakov Zeldovich, and it was called an Anapole. Anapole.
I'm familiar with Anapoles, yeah.
Yeah, so that's in 1954, and that is the basis. You have a current loop like that, and it's oscillating, and out of phase you have two charge plates, and they're oscillating. It's the basis for the patent in 1993 of
oscillating charge plates.
Oscillating charge plates, oscillating magnetic coil. It's exactly the patent from Hal Puthoff for his scalar and vector potential patent from 1993. And he's basically creating a monopole. But that is
an anapole is not a monopole. It's a.
No, I didn't say it was. I never said that. No point did I say that.
You just mentioned anapole and monopole. Never mind.
No, I was discussing Wisniewski's model for a topological monopole.
We're having a good convo here.
And then we went on to discuss the Anapole. Now, an extension of the Anapole was discovered in 1965 by Vladimir Dubovik and published in his thesis in 1967, and only first verified in 1997 in the West, basically largely ignored even by Ken Shoulders and other researchers. However, that being said, the description in the conclusion of Ken Shoulders' book, EV, A Tale of Discovery in 1986-87, says that we have found a perfect oscillating monopole where only scalar and vector potentials propagate outside of the structure. That is his description, and it's accurate for an anapole, and it's also accurate, although you don't necessarily see the oscillation, of a fractal toroidal cluster. And the fractal toroidal cluster is the anapole is the special case of fractal toroidal clusters, the hypertoroidal moment, as they call them in the West, and supertoroidal moment, they call them in the Soviet sphere. And you can look at this all up on Wikipedia. This is mainstream physics.
I should mention that these there are very many names for these now. There's like I saw flying donut pulses in some of the literature. Spatiotemporal.
It's not quite the same thing. It's not quite the same thing, because that's a soliton of circularly polarized. It's not a fractal cluster.
Not circularly polarized. It's
not a fractal cluster. It isn't a fractal cluster. It looks the same in pictures.
Okay, hold on, guys. Let me just read this. This is from Ken Shoulders' Tale of Discovery that Bob was just mentioning. It says we are able to say at present that the law of mutual charge repulsion has been overcome by the use of some unseen container, to the extent that a new freedom has been found in compressing uncompensated electric charge to the average density of a solid without the use of external magnetic fields, ions, or relativistic velocities. The exact physical mechanism responsible for doing this is still a mystery, but there are theories available to help us along that are based upon radiation containment from 0-point energy fluctuations. In spite of our ignorance of the details governing these observed processes, two conclusions are quite clear. One, that we have tapped into a higher order of energy and charge density, where even the effective values of certain basic physical constraints might be modified. And two, that a myriad of new uses will emerge. So I want to get your opinions on this statement here, because my takeaways are: one, A lot of the people that discovered this, they claim they don't know what is causing it. And that's why I wanted to get both of your guys' opinions on what are causing these EVO behaviors that seem to be, you could call it negative energy, anti-gravity, you can call it whatever you want to call it. But I want to get your opinions on that. He's saying directly there seems to be a link to 0 point energy here, which links to Puthoff, which wouldn't be surprised because they were partners. And then also he's saying that this might change physical constraints. So to your point, it sounds like he's saying here that if we, engineer the vacuum, or Puthoff would say polarize the vacuum, whatever it is, maybe we change things that we consider to be constants into variables. And now that significantly changes the equations when we're trying to, do propulsion. Let's start with one at a time now. One at a time. Let's start with Michael on this one, and then we'll go to Bob.
Thanks. I got excited about this one. So yeah, I mean, basically, people, there was, what was the Noether's theorem? She was saying basically the physical laws, like you have energy conservation and momentum conservation and all these conservation laws due to constant symmetries in physics. If you were to break those symmetries, maybe you wouldn't have the same conservation laws anymore. The other way of going is if you have higher symmetries, then maybe the conservation laws that we know are in some context not conserved, but in a grander context, you get conservation again of some kind. That's not necessarily energy or momentum or any of those conservation laws. As for the reason for the stability of EVOs, at the moment I have a lot of reading to do, so I can only speculate. But as I understand it, with Masahiro Daibo's work, for example, and the Hal Puthoff's communication technology patent and stuff, one of these patents mentions that there are two types of scalar wave. Actually, I should step back for a second. The electromagnetic equations quantum electrodynamics is usually considered the most general, the most successful physical set of laws produced. However, it's incomplete. There's pieces of it that were wholesale not included, and the main piece is this Lorentz gauge condition that's arbitrarily set to 0. So you get this scalar term, or what people consider a scalar term, which I call it time polarized. David Chester kind of cringes at that because that's not really the right explanation. But basically, we have a 3-vector idea of the magnetic vector potential. And there's really a 4-vector approach for describing these fields and potentials and stuff that's got a better symmetry for the physics we want to do. Now, the scalar term that the Lorentz can, maybe you're not.
Let me jump in and ask a real quick question on that. Are you saying that when you say there,
I have not even begun.
Yeah, I know. So that's why I want to ask a question, because people are probably already lost. Are you saying that if you add an extra dimension, that the equations can make more sense if you're conceptually thinking?
It was already there. It's a new perspective on all physics.
Yeah.
Now let me finish this. This is important. The scalar term has units of Webers, just like magnetic field. What does that physically mean? That means that it's a relativistic phenomenon. So we set it to 0 because it's Lorentz invariant instead of Lorentz covariant. But Lorentz invariance is a superset of Lorentz covariant. So now if you make magnetic field into a 4-vector notation object, maybe, then you have 3 spatial vector components of your magnetic field and a time direction component of the magnetic field. Then, so this new object, you can show how the standard magnetic field is derived by particles going past each other. But this component, the scalar term, it's derived by particles going directly towards and away from each other. And so there is, for a magnetic field, there's a special relativistic approach for showing that for justifying why basically you can derive magnetic field from electrostatics plus special relativity with two charge carrying wires, or even a charge with a wire next to it. This scalar term may require general relativity to justify why it should be there. But basically, the fact that it has units of Webers shows you that it's got a relativistic origin. You should be able to derive it from electrostatics and motion and then relativity. But that means that if you derive it only from general relativity, if you can't derive it necessarily from special relativity, that means it involves curved space-time in some way.
Yeah, stress in the medium is how I look.
And so you're modifying with the scalar term. In fact, I suspect that there is, for this virtual particle flux, there is your magnetic and electric susceptibility associated with the speed of light, E and B.
Yep.
If you have particles with mass, as well as electric charge that are virtual particles, there will be some mass susceptibility. There'll be mass density term almost associated with the vacuum. And you need that for longitudinal waves. When you derive the momentum of a sound wave, for example, you need the particles in between to all have mass, so that and compressibility, so that you get the longitudinal wave. But anyway, this all fits together quite beautifully once you remove the Lorentz gauge condition, which was an arbitrary choice. And so when you add it back in there, you get that you have this scalar longitudinal wave, and you have a wave involving just magnetic vector potential or something that Hal Puthoff's talking about. I heard, actually, I think it was in one of the patents by either Raymond Sigalinas, I think. I need to check the name. But certainly Hal Puthoff's patent and some of the other ones, they mentioned that you get two waveforms from this. One carries energy and momentum like a standard electromagnetic wave. The other just carries the energy, which is weird. And so maybe that other one is doing something unusual here. I don't know of any other wave type that only carries energy. So it's very peculiar. I don't know what that means yet.
Wow, that's cool. So real quick, I just want
to... So basically, extended electrodynamics.
Yeah.
There's a physical motivation for that from applying general relativity to electrostatics problems, and why you shouldn't have the Lorentz gauge condition. You know what? Even just like if you take a thermocouple, I was doing this experiment the other day for a random other project. If you take a thermocouple and you put the whole thing at a high voltage or a low voltage, if you just bring the whole voltage up or down on a thermocouple, then the temperature reading will change. That's because the electron gases inside the two metals in the two wires in the thermocouple, those electron gases are non-ideal gases. So when you change the voltage, the behavior of those non-ideal gases will change. And the equilibrium voltage that you'll see on the thermocouple when exposed to a temperature gradient will change. So we've just demonstrated from that experiment, as well as like the Arnaud-Bohm experiment and others, that when you change the potentials, you change the physics. So it's nonsensical to say that the Lorentz gauge should be set to 0 arbitrarily and doesn't matter for the physics. If you change the voltage,
Yeah, so for the people again in the chat who are confused, this is the big thing. When I've been saying that Maxwell's equations are where we messed up, Michael just said it in the way that the PhD people can understand. It's that basically we set this value to 0. And if you want to visualize what I'm talking about, I'll go full screen mode for you guys real quick. Is that we're sitting here and that we're in our universe. This rubber band being stretched. This is our equilibrium universe that we're in right now. And standard physics says this never changes. This never changes. That's what basically we're saying with the without the Lorentz invariance or whatever, the Lorentz gauge condition. We're saying this never changes. But then we're going, well, in extended electrodynamics, we're taking Einstein's general relativity and we are relating it to electric charge. And we're saying now that with that, we can manipulate the medium, that this is no longer, this rubber band here is no longer in a fixed position, that we were just feeling it in equilibrium, but we can break it out of equilibrium in any way like this. And
exactly.
If we do that, what happens? We get the math, the normal math, normal physics says that we get, like Mike was saying, we get some energy out of it. What does that represent? Go ahead.
Pressure on the vacuum.
And what is pressure on the vacuum? Gravity. Pressure on the vacuum is gravity.
Exactly. Yeah. You get gradients in your, when you pull a rubber band tighter, you get a higher wave speed along the rubber band.
Mm-hmm.
Or if you pull it less tight, you get lower wave speed. That's
red shift and blue shift, right?
Gravity does, but yeah, there you go.
Simple
and
as
anyways, the point I was trying to make is this extended electrodynamics. It has a lot of physical motivation for it, and it may describe the exotic vacuum objects. But I haven't researched that as much, so I can't say for sure. Maybe Bob can help us out here.
Yeah, so we'll let Bob go here, and then I'll, instead of just repeating everything,
Can you repeat the question, please?
Yeah, and repeating the question. So the points were initially, and I'm going to add a twist to it as well, is that when we were reading Ken Schilder's work, one of the first things that he's saying is that it's a mystery to him. So what do you think the underlying concept is? Is it the ether? Is it something else? Or vortex motion, what have you? Ken Shoulders connects it to 0-point energy fluctuations. So is that part of the answer? And then he also says that there are two things that we noticed. We have tapped into a higher order of energy, which in my opinion implies the ether. Ken Shoulders has said he believes in the ether. And that there are many new uses, that maybe this is some kind of tool out there. So I wanted to get you to respond to that. But because that's too easy for you, Bob, I also wanted you to respond to some of the research into how you might stabilize these EVOs as well. Go.
Okay. Lord Kelvin did not understand why matter could be so stable. He thought it was because of the smoke ring type thing. And the smoke ring is a very, the ring soliton is a very stable structure. But by 1904, 1905, he realized that smoke rings do dissipate quite quickly. And so do phallicosolitons. That's half vortexes rings in the water in the bow of a ship. So he kind of dismissed that idea. He never really considered fractality. But when you look at the work of Winston Bostick from 1948, he was at a bare minimum doing 2 deuterated titanium electrodes with 10,000 amp very quick pulses to vaporize and form a plasma loop. And these came together, these 2 plasma rings, because they pinched off and magnetically reconnected, and they came together and they orbited around another magnetic field in the center. This was at the very, very root of it, a tor made of 2 tors. That is a plasma toroids, plasmoids. And so when you start, and what we have found in our research is, and proven pretty damn conclusively in recent years, is that the smaller structures are more stable, the smaller they get. And if you follow that logic over and over and over and iteratively down, you'll get to a point where a fractal toroidal geometry is 100% stable in our ordinary vacuum. It doesn't matter what you do to them, they're stable. Now, there is a guy who lives just up the road to me, and after I went through a series of observational science leading to finding out that the Russians had this particular understanding that wasn't public and then, or really not recognized in the West, then another guy in Germany pointed out this guy called Pavel Ozmira, and he argued that, for instance, the electron is a fractal cluster of something smaller, which are self-similar. And if you go to the work of the last work of Dubovik, the discoverer of the toroidal moment, and his colleagues Karols and Shishkin, who I regularly speak to, they argue that at the bottom you have dark energy, right? I don't even know what that's meant to be, honestly, but I think it's just the vibrations of everything else and the sum total of that energy. If you add all of the energy up at all of the frequencies, that is dark energy. And that's most of the energy of the universe, right? That's all the stuff that vibrates, right? Different frequencies.
I have a comment on that, but I'll let you finish.
0 point energy. Go ahead.
Give me 20 minutes and comment at the end. That's the dark energy. Now, when you have that energy, some of that quantized into the most fundamental structure, that is what they call the elementary LC dipole, the elementary LC dipole. Now, if it is an inductor and a capacitor dipole and it's oscillating, that is the smallest anapole that exists. And that is the only unique case. And they call those relic neutrinos. They call those relic neutrinos. Now, an electron is built of a fantastic number of relic neutrinos. And they've done the maths on this. Unimaginable numbers of relic neutrinos form one electron. And then unimaginable number, you're actually seeing charge clusters in these experiments. I've got the same thing under my desk.
Oh, I know. I this is why I'm on it, Bob. I'm on the same wavelength as you.
Yeah.
Like I'm reading your mind and just finding stuff.
So the point is the energy is just, it's the vibrations in the ether. The ether is clusters of closed loops of energy, and that is the most fundamental thing, and everything is built from there. Now, what they argue is that these energy clusters, which they call magneto-toroelectrical clusters, they are observably through experiment across from 2009 to this current day, functionally equivalent to Ken Shoulders, what he originally called strong electrons, electron validium. Then he called them high density charge clusters because he realized that they were teleporting matter, right? And then lastly, he called them exotic vacuum objects because they behaved like vacuum objects, but they were exotic. And here comes the key point here. I'll talk about the formation in four bullet points, and then what that you get out of that. When you have polar, that is water, or charge separated material, that is plasma, and you put that in a situation of hydrodynamic shear, that is to say you have shear forces going on because you've got basically you've got a fluid moving across the surface, exactly what you're seeing in that ball right there. Multi-axis hydrodynamic shear. In fact, that's less multi-axis than it needs to be to do this, but it's not bad. When you get multi-axis, you get it quantizing into little balls around the big torus. So yeah, you've got the multi-axis hydrodynamic shear. This leads to self-organization into toroidal forms. And then as that breaks down, and there's a very good paper written by an expert in ball lightning who worked with Bitchkopf called Dijkhuis. He's a guy from Holland. And he shows, he describes this like, imagine you've got one torus and it's not very stable, but you put it down onto a table and it's a rubber band, and you rub that rubber band across the table and it twists up, right? Now, if each of those twists then kinks and breaks off into a little torus, we now know, and we know that this is more stable. Now we give it more shear and it twists off and it goes into another little torus, and this rinse repeats, and it happens at a fantastically fast rate with the hydrodynamic shear. And then these all link together initially through the magnetic moment of the very smallest quanta, and all the way up through the toroidal moment to the very largest quanta. So you end up with a stable exotic vacuum objects, plasma toroids, in the form of a plasmoid, and it is comprised of a fantastic number of very small, very stable things. Okay, so one, multi-axis hydrodynamic shear in a polar or charge-separated material, such as water or plasma, will lead to fractal electrodynamic structures which possess fractal toroidal moments a disruption zone. This is an area where the tornado comes out. It spins the ether so much so and pulls it in so much that it causes matter to fall apart. And it literally causes matter to fall apart in these quantized hexagonal vortices. And we've shown that actually in experiment. And then areas of change permitivity. The phase.
Mind if I jump in here? I want to just connect.
No. I need to finish this, please.
Okay, go ahead.
Otherwise, it'll just be broken up with all kinds of.
Go ahead, finish it up. I'll do it at the end.
Okay. So the phase singularity and Aharonov-Bohm effect at the center of the fractal toroidal structure leads to coherent matter, even of electrons in the magnetic core of self-similar substructures. So not just in the one big magnetic core, but in the little magnetic cores. And in the little magnetic cores, you have these fractal structures which all have this behavior. When fractions of the coherent matter at the core exceed their Schwarzschild radius, a black hole is formed. And I believe all black holes are these structures. This then produces a topological monopole with its own bubble of appropriate vacuum within which it can exist. It can stay in that state if it's fed appropriately. And Ken Shoulders identified that these structures of a certain scale can live in metals indefinitely. Why? Because on the boundary layer, it shifts electrons around and they get sucked in and it eats electrons. That's how it keeps itself alive. So it can persist in metals indefinitely. And then essentially at the end of the story, when you disrupt these things, electronuclear collapse can occur. That's the title of Matsumoto's book. When the fractal electrodynamic structures fail and matter is reborn into a range of column elements. We have physically seen this. And moreover, in the work of Binger and Huang, we have seen a large structure break up and two substructures come out. And then we've seen those two substructures out of one of the substructures, two more substructures come out of that substructure. Those were wheels within that wheel, and those were wheels within this wheel, this overall wheel. And what that shows you implicitly, no question and zero equations required, although it's compliant with equations already done that prove this, that it exists at stronger and stronger the smaller these structures get. They're more stable.
So they're more stable the smaller they get. That's a huge, or more powerful, more stable the stronger.
No. If we want to manipulate matter in our universe, we need to get them to a scale where they are stable in our universe and able to pull in matter from our universe and reorganize it in that core and its fractal subcores. And that's what it physically does.
Okay. So one thing I saw there, am I looking at, I think you might be muted, Michael, but
sorry about that.
Yeah, real quick, I'll let you jump in a second, Michael. I just had one follow-up, which is when I was looking at that image, and I'm seeing this self-organization. I clearly am looking at self-organization.
That is self-organization, but really it's not much better than a smoke ring. It's not much better than a smoke ring. It's like it starts to get better. It actually, when it breaks up into the beads, it starts to look exactly like the front cover image of Wheeler's Guillon's paper, the 1954 paper. That's literally the drawing on his.
Am I looking at negative entropy there? Like, am I not looking at just natural?
Neg entropy is self-organization. So yes, you are. It's a self-organizing process. Now, where does the free energy come from? The truly free energy. What you are trying to do in free energy, and I don't just mean gaining more energy returned over energy invested. When you're talking about really free energy, you are going to need to do what the atom itself does in our ordinary vacuum state. And what is that? According to Shishkin, Scrolls, and Dubovik, there are three components to matter. There is the electrons, the nuclei, and a condensed cluster of radial neutrinos. It's called an energy soliton. This is a magnetotoroelectrical cluster. They are in all matter. They're 2,000 to 4,000 times easier to release from hydrogen isotopes and any other element beyond lithium. Lithium is basically the end of the line to release these things. And every single one of those from one hydrogen atom can release nearly 10 to the 11 born electrons. That is called hidden energy within matter. It has no charge. It doesn't express its mass. But this cluster pulls in the ether, the relic neutrinos are all at 1.97 kelvins universe-wide. That means they're not at absolute zero. They actually have some kinetic energy, and there's a lot of them. And the atom breathes. It takes a little bit of energy out, and it keeps those electrons in orbit, at the right orbit. If there's too much energy, it sheds that energy back into the condensate. So they breathe energy in and out. Now, what you do with an exotic
thought, because I want to go at a different topic on relic neutrinos, but I want to let Michael respond to that after.
No. I need to finish the last part of that argument, and we're done.
Okay, because
that's a normal vacuum object, a normal atom maintaining its stability, maintaining its non-radiating boundary, right? Mm-hmm. In an exotic vacuum object, you are literally creating the same kind of structure as an ordinary electron and proton, even an atom, but you're creating it at an exotic state in our vacuum. And for it to survive, it needs to, one, create its non-radiating boundary. Inside that non-radiating boundary, it has to have a different space-time, and it needs to have this little arse where it sucks in ordinary matter from our vacuum state, extracts energy from it to keep it operational, and spits out the balance. And that's how it works, in my view.
That would be much more powerful than fission or fusion. That you could just take.
It's unlimited at any point in the universe.
Any old matter, yeah, or even the relic neutrinos, maybe.
And this is what was written in a CIA released document in 2017. I reconstituted this because they didn't think it was valuable. It was a newspaper article when scientists were defunded en masse in 1992.
Oh, I'd love to see that article.
It was people on the peripheral of the energetics program, and they said, this is 1992. They said, this is the same as the process as that cold fusion thing that they're talking about in America, right?
This is what I wanted to get to. Let me jump in here.
Well, I still have
the hidden energy from matter.
So I'm really glad that we got this chance to talk, Bob, and I got a chance to listen very closely to what you're saying, because I think I'm starting to be able to connect this to the existing physics, which is precisely what my criticism at the start was, is just connecting it to the existing stuff. So when we have shear in a superfluid, like superfluid helium can only take a certain amount of shear before it becomes an ordinary fluid. So there's
that might be something to do with the fact that it warms up.
Well, this is what's causing the non-ordinary vacuum state. You're taking, so even just actually before we even get to that, just when they have like gamma rays and things, the gamma rays never really spontaneously break into electron-positron pairs. You need to hit a plasma with those gamma rays in order to get the Bright-Wheeler process to happen. You need matter to be there.
You're thinking about this too complicated. I'll tell you where there's a non-ordinary vacuum state.
You need matter to be there.
Let me go finish.
Okay. Yeah, you need matter to be there in order for those gamma rays to turn into electron-positron pairs.
Yeah.
This has been shown many times over. Like the standard model, you would generally expect, okay, a high enough energy gamma ray should be able to spontaneously fission into an electron-positron pair, but you never really see it happening. I don't think it's been shown to happen, if I recall from the literature, but don't quote me on that. Yeah, that could still happen. Someone could figure out a clever way. But the important thing here is when you take an ordinary superfluid and you apply an extreme shear to that, and this is why you see in a lot of these like free energy devices, you see you have magnetic coils with opposite windings or opposite current flowing through them very close together. This creates a region inside there where you have zero magnetic field, but also zero magnetic vector potential. But what's not zero is something called the Hertz potentials and the Whittaker potentials. And so those Hertz and Whittaker potentials are, roughly speaking, associated with the axions and dilitons, which are the two types of excitations that you can have in superfluids. I'll take a look at that book later. Yeah, that sounds.
You won't.
Oh, it's rare to find.
You get it online.
Okay. Anyway, so, but what I'm saying here is like, all of these free energy devices I've seen, they have boundary layers with high, which would be applying high relativistic shear to the vacuum. And under those conditions, it makes sense if the vacuum is some sort of superfluid medium that high shear would break the usual behavior of the vacuum, and it would start behaving like an ordinary fluid or a different fluid. And then everything in the vacuum that's interacting with the vacuum would start to exhibit a different behavior. So that's starting to make sense to me from the
it's like a bubble,
from
right?
analogy
Like a bubble.
from analogy with existing physics. The other thing I just wanted to mention, the dark energy and dark vacuum, dark matter. Dark energy and dark matter are they're epicycles. They're epistemological epicycles. Like before we switched from geocentric to heliocentric theory, those will be going away. There are better explanations. There's something called.
Oh, I'm glad you said that. Can I share you some slides today?
Okay.
Hold on. No, we're not going to. No slideshow.
This is totally happening. This has
another
never
one.
been shared in the West, and it was shared today by Dmitry Baranov today. The world's
there is a
largest
paper in the
cloud
West
chamber.
as well. There is a paper in the West as well. The interior Schwarzhild solution. So basically, assuming the universe is a black hole, which if you calculate the matter density and the size and things, yes, the universe is kind of a black hole. From our reference frame, everything else has been falling far away from us, has been falling into the black hole for less time than we have. Assuming we're using light as our means of determining what, like, because we're looking into the past when we're looking at normal light. So we see a redshift because we're falling into the black hole faster than that stuff is. That's why we see a redshift. And the dark energy is just the entropy increase in that. Basically, once you form a black hole, the volume inside the black hole starts growing based on entanglement, and that gets to ER equals EPR and Susskind stuff a bit. Anyway, that's all I wanted to mention there.
Oh, can I respond to the fact that
it's my turn. It's my turn. I've waited. Listen to both of you. It's not going to take very long.
We're trying to wrap it up before 2 hours. I mean,
yeah,
like
and we're going to end up going over my 2 hour limit. That's fine. But I'll let you guys get out here pretty soon. I just wanted to point out that, Bob, you finally got to what I was trying to get you to say all along, which is you kind of explained the idea of the ether and how the ether is what's sustaining these EVO capability. And then this does add this energy where now, as Michael was saying, we can basically break this conservation that we see from our current perspective of physics, from the mainstream perspective. But if you add in this idea of ether, well, it's still conserved now because the energy that we were not conserving before is now just being exchanged with the ether. And I think that's what he meant when he's saying, like, bring back, Lorentz gauge condition kind of situation. Maybe I'm wrong on that.
It's required in order to when you bring back the longitudinal modes, you see that there's this the Hertz and the Whittaker potentials connect electromagnetism to a Yukawa coupling and basically a superfluid behavior. There's a superfluid behavior here that's intrinsic to the potentials and the superpotentials for electromagnetism, a couple derivatives up, but it's the same structure, and the electromagnetism falls out as part of this superfluid behaving structure, but it's not always a superfluid if you apply enough shear, it seems.
Yeah, if you break the symmetry of it, imagine we're in equilibrium. If you break that, then you can get it to behave differently, and that's what I think Bob is basically saying, and potentially what the overall secret of cold fusion might not just be, oh, well, we figured out a more efficient way, maybe a way that seems to be what we would say impossible, efficient way. And instead, what we found is this property of the universe, which if you want to call it the ether, great. If you want to call it 0 point energy, great. If you want to call it the neutrino flux of the background, great. Call it whatever you want to call it. But the beautiful approach of it, which was also something that Puthoff wrote about in 1987, which was the ground state of the hydrogen atom, is that, in my opinion, and I think Bob just said this beautifully, is that you imagine that like all the atoms are breathing energy in and out. That's what keeps them in this equilibrium state. So that's why they're so stable all the time. Otherwise, they shouldn't be stable.
Non-equilibrium steady state. It's a non-equilibrium steady state. It's an important distinction, and we'll get into that in another.
Because they're broken
when we talk
out
about
of
the energy.
Yeah.
We'll talk about that. Sorry.
But that's great. And this conversation is awesome.
Specifically non-equilibrium is that not every single thing is exactly the same kinetic energy.
Yeah.
Fair. And steady state versus equilibrium is a very nuanced topic, so it's a conversation for another time. But
okay. So two more things, because Michael, I want to address the superfluid discussion, because when you were trying to bring this out, you were saying, okay, I want to get the academics back involved in this. Think about superfluidity, superconductivity, superfluidity. We're looking at quantum effects on the macroscopic scale. We're seeing things that are separate acting as one. And this is also then what Bob is saying, is that what if we're using this same phenomenon? What if our plasma, our EVO that we're producing, is superfluid? What if it's a superfluid circuit itself?
Well, so I should mention one thing where I don't know if I agree yet with Sal Pais on this one part. He calls it macroscopic quantum coherence, but that's assuming our current understanding of quantum mechanics. If we have to make a correction to quantum mechanics, if we have to make a correction to classical electrodynamics with the longitudinal scalar term, and maybe I'm wrong here, but if we have to make a correction to the classical electrodynamics, we have to revise quantum electrodynamics. So what we see as a macroscopic quantum effect might be a type of classical effect that we hadn't considered yet. And so to back that up, there were these things called squeezed vacuum states. In vacuum, you can have this propagation of vacuum noise as a wave, in the form of a wave. And these squeezed vacuum states, they propagate like a particle. They have all the basic properties of what a particle is, but people don't call them particles. Why is that? Because in quantum mechanics, when you take the square of the wave function, you don't get a probability of 1. You need to use something else called the Wigner quasi-probability distribution, because by definition, a squeezed vacuum state is not a particle on its own. We have defined it not to be a particle. So, of course, when you're trying to use a squared wave function that is meant to understand the particle zoo that we already have, and there's this other particle there that's just not part of that particle zoo, it is excluded from that system. But when you use the Wigner quasi-probability distribution, you get a probability of 1, like a normal particle. And so there's something classical in classical electrodynamics that we missed, and we now have to rework that into quantum theory. And a lot of physicists are going to be a little upset about that.
I've got a video you can watch, my brother.
They shouldn't be, because that's years and years of work. So it's a little depressing at the start, but now they won't have to worry about losing their jobs because of string theory. So there you go.
That's great. And I've got a video to show you on that. We're not going to have time to go through everything I wanted to go through tonight, because it's great, but I'm going to let Bob respond here next. But before I do that too, I just want to say the other thought I have out there is that, okay, I'm just going to say it, from the MH370 videos, there's no material confining the balls. Those are clearly balls of amorphous plasma in those videos. So if that's real, then somebody's figured out that their tokamak or whatever doesn't need metal container at all. And that gives credit to the idea that Bob is saying, is that somehow they figured out a way with just waves alone to stabilize it into a sphere where the energy is not able to radiate outwards. Otherwise, a ball of plasma should just dissipate out like fire does or something, right? And disappear. Or lightning, like lightning does. Okay, go ahead, Bob.
Well, I do agree that there's going to need to be jobs for people in string theory, because string theory is just a monumental waste of billions and billions and decades of people's intellectual capacity.
They're welcome in condensed matter physics.
It's my time.
Okay.
It has 10 dimensions, and like they're the easy versions. And you don't need anything more than the dimensions we know and can feel and touch in the exotic vacuum object theory. It just needs nothing else, and everything is explained, right? So you don't need to make new dimensions. In terms of neutrinos, I'm literally looking at something that's never been made public in the West right in front of my screen. And it took 27 megawatts of power and a 70 giga-electron volt protons. And this chamber is just amazing. And so you said no presentation, so I'll do it some other time. But this has never been seen outside Russia, and because it was Alexander Parkhomov's celebration birthday, he's 80. He was on the end, but they celebrated it today, the Russian community. I got to see this. Very much so. 100% neutrinos are a real thing. I'm sorry you haven't got to see them, right? Or you didn't have the capability to detect them in the West, but they have been detected, right? And if they are at a range of energies in this detection device, they will be low energy neutrinos, and they are the thing that Parkhomov established in his work here, following doing the psychic spy program research, which he went into more detail during today's stream as well, which was absolutely fantastic. And it was only because he did that work that he could find these structures. And they are able to do inverse beta decay. And so whatever you think does weak interaction, these things can be lensed into a target. And if you think it's a weak interaction that's mediated by the neutrino doing the mediation of the weak force, then 100% these are neutrinos that are a real thing from both ends of the spectrum. Large physical experiments and experiments you could choose to do yourself if you wanted to. So they are a real thing. So those people that don't think they're a real thing and are moving towards trying to write them out of the equation are going to find a problem with explaining how things work. And so with that said, we have an opportunity in front of us, and the experiments that I was shared to today it's just freaking amazing. But what is going on in the West is they're focusing people on metal hydrogen energy. Why? Because they can be made into propellants for missiles and torpedoes. Flat out, that's why it is. Right? It's not to do you any favors. And that's why in the West, they're spending so much money in the military circles and military and university contractors. It's to make better, faster, and the calculation is it's about 1,000 times more bomb when these things are turned into bombs without being nuclear. So they don't have to use nuclear bombs, but they can use material that's 1,000 times smaller to do the same damage. So you want to know why they want to keep this wrapped? That's why. You can go and have a look at this. It is the Alice rocket from Purdue University, Pennsylvania State University, and they used nanoparticles of aluminium and water in their ice. It was frozen into an ice block, nanoparticles of aluminium, and Anatoly Klimov knows 100% that this produces LENR, because when you put that mixture into his Vortex reactor, which is what NetIQ is based off, because NetIQ worked with Anatoly Klimov's partners, and then NetIQ was working with Engate, and Engate took that technology on. So it's all Anatoly Klimov's work, right?
Send that to me after, because I'd be curious to see that. So
I've
been translating it, but yes, it's a lot of work.
My thesis advisor was Russian, so he would be able to.
I'm pretty proficient at it. It just takes a little bit of time to churn through.
So, guys, we're running out of time, and so one thing I just quickly want to show Michael and everybody that's out there is that, because we've been talking about waves, and one of the things I think maybe Bob was talking about as well. Where is it? This one. Okay. Is this idea of a resonating cavity, let's say you have your cavity walls shifting. This here is a clip from actually an APEC presentation by Rob Chambers. He's looking at this Lockheed Martin engineer's book named Larry Reed. And what's happening here is they're taking a standing wave, and then they're shifting the walls of the wave, of the cavity, like this, oscillating them. And that oscillation causes this phase shift to occur. And this is actually apparently similar to how they do like attosecond lasers or something like that. It's kind of how I found this. But I don't know. Take a look at this potentially when you get a chance, because he talks here about, I think, coherent matter waves.
Yeah, that's that book with the cover with the that has the squeezed vacuum states in it. That book, or
this is the squeezed vacuum state thing right here, because this is what squeezed vacuum state. That's what he's doing, right? Is
kind of.
The idea of a squeezed vacuum state is you're just squeezing the vacuum and therefore changing the modes.
Well, what he's got here, with the descriptions of pushing the boundaries, that's called a parametric interaction, or possibly you're messing with the boundary conditions for is different than a parametric thing, maybe. But yeah, I mean,
Anyway,
this phase computation was described by Tom Bearden and many others. I'm still figuring out what they were talking about to some extent. I'm not sure it's the
just
final.
overlapping waves, constructive and deconstructive interference.
Just
So if you
look at the 1950s explanation by Piotr Kapitsa of the formation of ball lightning. He says microwaves come down, reflect from the ground, they produce a standing wave, and because they're reflecting, it's phase conjugated. And he says transverse to the standing wave, you get the formation of the energy structure that produces ball lightning. That's exactly what we do in our ultra experiments, but with sound.
Yeah. They've clearly just figured out how to manipulate the boundary conditions, create a standing wave, and then probably even modulate it. Like, why not? Right? If you
can also create nodes by interfering waves. So you have
that's what the EM drive was doing also.
Yeah, and in fact, this mentions the EM drive. That presentation, I'll put it in the chat. We're going to review it on one of my next slides.
You need a nonlinear medium to do phase conjugation properly. That's the thing. They were so like a lot of these early experiments, they were studying longitudinal waves and things, and they were just using electromagnetic coils and capacitors. And when you add a nonlinear medium, that's when you start to see strange effects. Many people mentioned this. Floyd Sweet mentioned this. Tom Bearden mentioned this. But that nonlinear interaction term breaks the symmetry that keeps you from getting these sorts of effects.
So, and this is important because really what I'm getting at here, and the whole point of this cold fusion research, is that I think that ultimately one of the secrets here might be that when you start to get these anomalous effects due to whatever it might be, the breakdown of the vacuum or whatever it is that we're doing to break it out of equilibrium, some of those effects are dangerous and scary. It is very possible. Like, we're seeing claims where all of a sudden we're getting to 800 over unity or 600 COP or whatever it was that Bob was saying. And so now it starts to be a question of like, we can make a weapon out of this. Like, you can imagine, Rye, you could see a reality in which the story goes that John Archibald Wheeler, Richard Feynman, and others figured out this secret, and that they could produce a weapon that basically had no limit, and just realized like, okay, this is something that like we have to keep hidden for the rest of time, for as long as we can literally keep it hidden for.
Well, it's just beyond weapons. You can re-engineer
reality,
physical reality, however you want it to be. That's the power of gods, and we're not ready for it.
And Salvatore Pais literally says that in his patents and his papers, is that you can literally
and yet
reality.
And yet it's clear that they've already done it.
Yeah, I think they've already done it. And that's the part where, Michael, to your point, is we're not ready. Yeah, we're not ready. We'll probably never be ready. Not us as human beings.
No,
and if they've already figured it out,
we're not ready, but we're right to be manipulated by it.
And this is exactly what I wanted to transition into for our last topic, which is, how do we get it out? And do we get it out? Because now I'm talking to two people who can understand the implications. Most people, I see this stuff in the MH370 videos, and in my mind, I go, why can't that just get bigger? And the answer is it can, because it's scale invariant. And so you look at that and you go, okay, there's no limit. We can make a big bang, right?
Well, I know. Can I go first on this one?
Oh, yeah.
Sure.
Right. We already use it since the 1920s in electro-wire discharge machining. Okay, it produces these spherical balls that are able to cut even up to tungsten carbide using just deionized water. That is your dielectric through which the spheres form, and as a source of hydrogen, and a 300 micron wide. That's a wire that's 1/3 of a millimeter. You're able to cut through, for instance, even tungsten carbide. So, and when you look at that under the microscope, it was never explained, and I was able to explain it in literally 90 seconds from looking at under the microscope. In the case of HHO cutting, we've proven that it produces these clusters that can transmute matter. We did that in 2019 in Japan. When you do HHO cutting, you can go and see these videos in China where they used HHO or Brown's gas. The plasma is coming down, it's very close to the metal, and it produces these extreme hydrodynamic shears. It produces the coherent matter, and it will cut through 1/2 meter of steel very, very cleanly. So there's two methods directly, which are already used every day in industry. So there are ways this technology can be used that you can go and interact with. Then ultrasound is doing it. So we have a project that I'm supporting called evolabs.io, and several of the things that I've identified, these are patents that have expired of technology. And you know when you're on the right technology because all of these military types pop up and try and attack you. And that happened literally when I was talking about this technology from a guy called Kladov, who was even dismissed by his own Russian counterparts until after he died in 2003. And then they verified that his approach could remediate beta isotopes, which means it's a weak interaction, which means there's some neutrinos involved somewhere, pretty much instantaneously in the hydrowave reactors. And this is in a only partially disclosed, declassified document from 2009 for the Department of Energy. And I've shared those references before. And that was in 2006 and 2009. So this is remediation of nuclear waste. Once you've got remediation of nuclear waste, you can use normal fusion and normal fission rather with impunity, because you can have small nuclear modular reactors everywhere around, and you can run the remediation of these things and the waste that they produce very, very easily. The argument, oh no, we're going to produce a little bit of radioactive waste, what do we do with it? That argument has stopped. And so, you know, that enables unimaginable amounts of energy from, for instance, like thorium. There is so much thorium, for instance, in India alone, in just Kerala alone, there's enough thorium to run India for about 300 years if they replaced all their energy with thorium. So like there's tools, but what you're going to be doing is using cold fusion to fix or exotic vacuum objects to fix the waste, right? And what Klimov's saying today is basically when you use plasmoids, you always get transmutation, period. And you know, Buldarova was on there. We had Savatam over, and they were saying, like, you know, all of our experiments produce these transmutations. So the problem is the West has been so stovepiped with their textbooks and their equations to make sure they can't ever discover this, because they're just bounded by all these very great things that they can spend a lot of time writing papers on, like string theory, that they never get anything useful done. Meanwhile, when you actually try this, like garage researchers like Henk Uren did, you know, I visited a guy called Jan Rack in Prague. He's going to be replicating Henk Uren. He worked at CERN. He worked at some of the national labs in the US. He's gone, I never got anything really useful out of that entire part of my career. Now I want to do what you're doing because I can see it works. So we are at a stage where we are taking this for ourselves, and that's how it always had to be. We could never rely on these people to give it to us.
Counterpoint, you're not wrong, but how under 5 minutes, how long does the Earth last if we give everyone in the Middle East a neutrino bomb? More than 5 minutes or less than 5 minutes? How long?
Well, actually, most people just like to get on with their lives. They just do. They just
only
like
takes one though. That's the problem. That's the problem, right? Like I'm steel manning the deep state argument for why we're not ready for it. Their argument is simply if we give the
I'll give you a reason. These things need to be small to be stable, right? And I can tell you, when you make a reactor that works and it runs for a long time, it's going to destroy its environment that it's in. And when you switch it off, it won't work again.
That's not making me feel safer.
No, I mean, that's a matter of engineering, Bob. That's not a matter.
It's not.
Yeah,
No, it's not. No, there's no matter that you can make with all the nanotechnology in the world, because you're going to be making all that nanotechnology out of ordinary baryonic matter, which has a lower binding energy than an exotic vacuum object's boundary layer. And so it always vanquishes any ordinary matter. It's not a matter of opinion. You're
the one who says that you can you can put an object in your little toroidal structure and teleport it. You said that there's a safe zone.
There is a safe zone inside, yes. Oh. I'm talking about the boundary. When you make a reactor to produce energy, you cannot bound it in something in ordinary matter. You can use fields, but the fields have to be bound in something. And what this does is it chucks out these substructures periodically, which are very hard to contain. And that's what's melting tungsten and lithium on the inside of tokamaks. And they know that, right? They just won't admit it. They did have one of the researchers we work with go to CERN to tell them, oh, this looks a bit like LENR experiments. And so they know that. But it will destroy the reactor. But you can get a reactor to run almost forever.
You don't think we can destroy it? You think that we can't make something?
One, it's already been done. Two, when it's operational, as long as you keep it operational, it bounds itself.
You
Hold
also
on, one
said
at a
it's
time.
like 1,000 times more powerful than a nuke. So like, it
No,
can't
no,
be
no, no,
both.
no, 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 no. You keep it bound at a quantized level, and it has
You
its
can't
own
expect everyone
boundary.
Like if you have some crazy person who wants to blow up the world, like they're not going to listen to that. You need everyone to be trustworthy. I know already a bunch of people who have these devices working in their houses. They sell them even, if you know where to look. I wouldn't say where it necessarily, but like
Put them on the full screen, chat.
that's because they are trusted.
Show me the money, mate. Show me the money.
Flip this chat.
That's
Don't talk
because
the talk.
that's because they are trusted to an extreme degree with these technologies.
Oh yeah.
So like, and they.
I'm sorry if
they-
you're an also ran who said I had something. I just don't believe it. I just don't believe it. Right,
Bob, you're the one to say you don't believe it.
No. I'm the one to say that if someone says they've got it in their house, I don't believe it. Show me it. Show me it, because I've seen.
No, I'm
Everyone
just
tell
saying.
you
I'm just
show me
saying
it.
that like,
Okay, go
if everyone has, it's like, okay, the gun debate. If you're in the countryside, you need to protect yourself from a bear or a break-in, and the police are 2 hours away, you need a gun. Sure. If you're in the middle of the city in an apartment building with 10,000 other people and 100 of those people are crazy, then any of those people could be crazy and have a gun. That's a different lived environment. If you have the world and then suddenly everyone, including crazy people, can build a nuke in their garage.
See, finally, I'm talking to somebody who understands the implications. And no disrespect, Bob, I love you, but I feel like a lot of people have this fanciful, optimistic view. And this is where I can agree with the deep state gatekeepers, where it's like, no, it's definitely going to be the end of the world.
You
Like,
need to
it's
go back
definitely
and
the end
look
of the
at what
world.
I've said. You need to go back and look at what I said. In 2017, when I realized that this had already been made, I had a decision to make. Walk away with my reputation intact and everyone liking what I did, but not being able to move forward in the field, because I knew I couldn't move forward in the field unless I used the technology that it actually runs on, rather than what you're being told to try and find out whether it runs on, right? You had to look at what it actually works with. And the implications of that, and realizing that they'd already weaponized it in specific cases where they'd used those weapons before I ever realized what I saw when my friend sent me those videos that you've done lots of things on. I had to think, do I have to accept to the end of my days that everyone that I know has to toil hard based on a lie and live in this world of a lie, just because I think my precious should be my precious?
That's
right?
a good counter argument. It's like, should we just live a lie?
I want the
because we're afraid of the
positivity to
power?
come out of this, not the negativity. And what I'm talking about is a little reactor that's millimeters across and can produce all the energy for your home. And you know, yes, if you put it into a drone and charge Evo weapons.
Am I here? Am I
Am I
back?
back?
Okay. I'm back.
You lost me for a second. What I missed?
I just said that
Evo weapons is what I heard with the drones.
Yeah, so if you had an unlimited energy of any type whatsoever, you're going to have drones that can fly around forever, and they're going to be able to use electromagnetic guns and shoot whatever they want. But so
what?
All right.
So here's the truth. Here's the dark truth. So like basically this is the power of gods, and
yes, there we go.
Well, we're in for a difficult time the next 20 years. This is legitimately an evolutionary bottleneck. But the cat's kind of out of the bag now. The momentum is already building for this. We are a species built upon evolution, and the greatest of wisdom comes from successful adaptation to the greatest of suffering. So it's going to be a rough time, but we can get through this. And I guess Bob's right in a sense, is like, now we have this, we need to learn to live with it. We need to learn to be okay with each other.
Ken Shoulders only censored one paper that he wrote in all of the papers he wrote. It's called Disruptor.pdf. He also wrote another treatise on electromagnetic weapons. He says sooner or later, everyone will have electromagnetic weapons. If you have a normal weapon, that weapon will kill you because you shoot an electromagnetic weapon at it and it'll cause the munitions in that device to blow up. So you'll be killed by the thing that you're using to try and defend yourself. I guess that's what they call these things.
But I mean, you can't trust that everyone in our current situation, in our current society. Okay.
Well, they said at first, he argues to the whole situation. He says at first they'll try and legislate against it, but it's so easy to do that people will just do it anyway. And sooner or later, everyone will have to have one. Then everyone's on an even. So my view in 2017 was you have an asymmetry in the world. And what you've got is you've got some countries that have got these weapons. And if you have a situation where this country gets replaced by a person who's autocratic and is a little bit mental, you already have the problem you're trying to solve. And they've already got the weapons at the deliverable state. So what are you worried for if you're just giving it to everyone? You're only slightly changing the timeline.
That's true. The only people who have used a nuke are the countries that are trying to keep this secret in the first place. So like why do they
and that's it. And in a billion years we get engulfed by the envelope of the sun. So it doesn't really matter. There was nothing here to begin with, and there's nothing here in a billion years.
When everyone has free energy, they have a lot less reason to fight.
But so we have an ultimate destiny, which is be fried by sun, right? Fried by sun.
Fried by a black hole super 0 point super.
Whatever. But in a billion years, the sun is predicted to engulf us, right? So that is always the end game. So what we need to do is use this technology to become a multi-planetary species. And I would argue multi-galaxy species. And that should be the prize that you should hold on to. Yeah, sure, some stupid people are going to shoot at some stupid people. And if they total the planet, then honestly, it's going to be totaled anyway. And we all die, so get over it. Right?
Well, hold on. Yeah,
why even live on a planet if you can live in space? Gravitational well is also an economic barrier.
You can't. You don't have enough neutrino flux in your body to keep you functionally alive. Your calcium starts falling apart. All your biological functions start
falling. I'll have to look into that.
I am interested if you
don't have the flux of chi, you cannot live. And you need the planet to live on. And we evolved with the planet we're living on.
One thing I want to point out is that I think thinking that we're going to live for another 4 billion years is pretty naive. I'm worried about us surviving for another 25, 30 years. And it's not nuclear winter I'm afraid of. It's total annihilation. I mean, I think you made my arguments for me, which was basically that this technology is going to become ubiquitous, like very quickly. And this is both of you guys, by the way. So that's what you said, Bob. And then Michael's like, yeah, you can't hide it for very much longer. Like people just randomly have free energy devices, but they're trusted with it. So, we let them have it and maybe build it for people who are also trusted. It's crazy that kind of stuff.
Yeah, but there's levels. Benjamin Huang has a device that produces 4.6 COP. Klimov has a device that produces 13. We're going to replicate a device that was developed in the 1980s that produces a COP of 13. These things are not earth-shattering, but they're transformational to societies. But they're going to be very, very disruptive to oil-producing nations. The threat actually comes from oil-producing nations rather than terrorists. And if we think they're terrorists, they're not terrorists. They're oil-producing nation-funded terrorists, right?
I want to say that I'm just playing devil's advocate in some cases. Obviously, I'm for disclosure. I'm like one of the main people out here pushing for the disclosure of this stuff that I'm also saying can destroy us. I just want us to have an honest and realistic conversation about the dangers of it, because we cannot just brush it off.
We all die anyway. The planet will be destroyed ultimately. Right. We need to be able to get off this planet and spread our seed.
That's exactly my view as well. Is like, hey, let's just get the technology, try to get out of here before somebody wipes us out. Maybe that's how this has got to play out. Maybe that's why we're here in the first place. Who knows? And the other thing I want to say is, because I think that the whole plan of this UFO disclosure thing, I think this is what the big secret is, what we've been talking about tonight, is that at the end of the day, they figured out some secret property of the universe, and it's the ether or something, and they figured out how to get like huge amounts of energy out of it, which we would call free energy. And that explains why they've been hiding all this weird stuff and what have you. But like you said, at the end of the day, they're thinking, oh, we have to get like people to wake up and then like become ready for this technology. And like Michael said, we're not ready, and I don't think we're ever going to be ready. So
I have seen through my life,
we will have to
one at a time. Go ahead.
Yes.
I have seen through my life extremely disruptive technology come in, and humans have always sucked it up. We are incredibly adaptive species. That's why we run this planet all over this planet. We can live in the coldest climes to the hottest climes. It'll just be another bump in the road. Yes, it'll be very, very significant, but we, in my opinion, have already used this technology, and it is our birthright. And sentient entities will, unless they're really, really stupid and are not paying attention to how nature actually works, they will be using this technology all across the cosmos, whether anyone told them or not. It's an inevitability that you will understand how the root level access of the universe works.
So this is perfect, actually. Ashton, the question is, do you think someone will blow up a city first? Or do you think that someone will decide to homestead on an asteroid first? I think a lot more people would be interested in homesteading on an asteroid than blowing up a city. Yeah, a lot more people, and more competent people to get the thing faster.
Michael, this technology, as I said from the outset, is just not very good the bigger you make it. You have to work harder and harder to make it stable at a bigger structure. It's an implosive technology. It wants to bring things into it, not throw it out. So, it's a cold.
Let me address that, because this is something I haven't said, or maybe only said once on a podcast, which that's a great point. This is where I would disagree with you, Bob. This is where I think that Michael is right, that it's actually just an engineering challenge to take something that's very
it's always engineering. Yeah, you do it with fields and you don't switch it off.
And so,
so there's more than just energy tech here. You can.
I want to make one point, and then you can jump in, which is that I asked Salvatore Pais in some private conversations about this, because I think that a wormhole and a black hole are really the same thing, and that the idea is that when you make the black hole the wormhole, it's going to instantly close back up, because you're breaking that symmetry of that energy, and then it's instantly trying to fill in. Just like if you're trying to pull water out of the ocean, it's going to fill in right away. I think that same thing is potentially happening. And then I asked him, or he sent me a paper. And the paper was basically arguing we would never be able to make a black hole because it's essentially going to collapse and break down too quickly. And you know what Sal's response to me was when he sent me that paper? This paper will be proven 100% wrong one day. That's what he said.
We make black holes every time when we're doing these experiments. It's what a black hole actually is, rather than the three different mutually exclusive things that people tell you.
So the important thing here is, like, you can manipulate energy in interesting ways. You can also manipulate momentum in interesting ways. If there's this sea of particles, you call them relic neutrinos. The existing physics community calls them axions and dilatons.
Well, axions are clusters of relic neutrinos.
Okay, same difference. Same difference. But anyway, so axions in the superfluid context, there's what was it? There's some vortices in the superconductors. I forget the name, unfortunately. But yeah, vorticity in superconductors. You can look into it. And superconductors and superfluids, they have two behaviors. They have these quantized vorticities, and you have Bogoliubov waves, which are like the squeezed vacuum states.
Apparently known as fluxons or Abrikosov vortices.
Abrikosov vortices. Thank you. Yes, that's the one. But yeah, you have these two properties of superfluids in the vacuum, and these are giving you, I think, the exotic vacuum states, or allowing these to happen within the extended electrodynamics framework. And those superfluid behaviors, if you can't just push off a superfluid in the standard way, but if you figure out how to impart that momentum, then here's a material medium instead of like rocket fuel that you can push against. It's like paddling a boat instead of using a rocket and throwing your propellant out the back. You're surrounded in an ocean of propellant. You can sink. You can exchange energy with it, but you can also exchange momentum with it. Large amounts of momentum. Anyway, so
talking about being in a something, put yourself in this imaginary. Just do this thought experiment with me. Imagine yourself inside a proton. What makes that stable? What is the space that you're looking at when you're sitting inside that proton? And in theory, in our vacuum, it's stable for all of time, right? It is its own little space-time bubble, and it doesn't radio electromagnetic waves. Yes, it has a charge, but it doesn't radiate electromagnetic waves.
Well, you can think of an electrostatic field as an electromagnetic wave with a frequency of 0. And so it's always
Okay.
transmitting
Go
at zero energy.
step out from the outside and go on the inside.
Well, we don't have in the
inside?
standard model a way of explaining that. And so this could explain that. But
Interesting.
I need to learn more for that. So I can't really help you that much with that.
Okay, well, guys, we've been going for 2 hours and 30 minutes, and
Yeah.
I think I want to wrap this up. So I'm thinking that what we should do here is just do final thoughts and shout outs to whatever you want to shout out. Also, I want to say this was a great conversation. I learned some amazing stuff. I think that the viewers probably learned a lot as well. Sorry for any issues that were there. I'll try to edit those out and maybe re-upload this later. So let's go ahead and let Bob go first. Thank you for being with me here today, Bob. Go ahead. Final thoughts and shout outs.
Thank you very much, Michael, for being here. And thank you, Ashton, for hosting this. I really want to thank you again for your determined effort to do whatever you can to get some disclosure. That is really commendable. I would like people to direct people to my blog, which is at remoteview.icu, remoteview.icu. If you want to subscribe there for free, that's great. If you want to subscribe and help me, that would be good too. Also, please look into the project, which is to set up minimum viable products of various out of patent patents that I believe work. And that is evo-labs.io, evo-labs.io. And lastly, the Martin Fleischman Memorial Project at MFMP on YouTube, at MFMP on X and Facebook. And you'll see all of the work that I have done now. It's just amazing. Speaking to Alexander Parkhomov today, he signed this book for me when I visited in Moscow on the 27th of the 2nd, 2015. That is now over 10 years ago. You can't really see it there. I need to get that before it goes. We are at the new dawn of an old age. We have a technology literally at the tip of our tongue. It's right there for the taking. And I think we can do it. We have to do this ourselves. We cannot rely on anyone to give it to us.
Yeah,
Excellent. Go ahead, Michael.
Cool. Again, thank you, Bob. Excellent conversation. I learned a lot. I think I actually had a few breakthroughs while we were talking, and I was really like thinking about what you were saying. That really connected the physics together for me in a better way, and I hope that other people can take those connections and do useful things with them. And thank you so much for hosting this, Ashton. I guess in terms of name drops, I guess APEC, the Alternative Propulsion Engineering Conference, they've been great to work with and collaborate with over the past couple of years in discussing these projects, including exotic propulsion and energy technologies. So definitely go check them out if you liked this conversation. I have also a Hackaday page for any engineers and makers who are interested in participating and contributing and collaborating in any of the open source projects that we do. We're actually looking for RF engineers and power electronics folks to assist us with some of our work. So Ashton will drop some links in the description when he does the re-upload, I suppose, or when maybe he can edit this description. But we have our own company, Sanrel LLC, as well, where we do similar research to what Bob's talking about.
Yep. Awesome. Thanks, Michael. Yeah, I went ahead and added those links in the description already, and I'll do that in the upload too. So thank you guys both for being here on this episode of Hard Truths. You guys have a great night. I'm going to drop you guys down just to go through some of the super chats and just thank them and then end the stream. So thank you guys both very much. Appreciate you for being my guests and this awesome conversation. Can't wait for to do more in the future. Later, guys.
Thanks, Ashton.
Okay, guys. So I just want to go through some of the super chats because we had some amazing super chats here today in the live stream discussion. And thank you guys for being here on this Hard Truths live stream edition episode of Cold Fusion. I hope you learned about cold fusion and kind of the science behind how fusion research works. Mark Scott, another fantastic podcast, huge donation. Thank you as usual. Truth Teller, thank you very much, brother. Thank you for this donation. Very civilized conversation. Sorry, a lot of us are just really excited, so we were talking over each other. I tried to keep it to a minimum. Hopefully it was fine. Lisa, Confused about the physics. Hopefully you learned a little bit, Lisa. Hopefully you learned a little bit. If you didn't, that's fine as well. But hopefully you did. I think that there was a lot of really good information there. Sackeriker, thank you very much. Bazing for that donation. Appreciate you. Oh, second donation. Thank you. Look studious. Guys, I dress better for my live streams than I do in real life. Lisa with the follow-up. Oh, you're putting technology on the grid. Thank you, Lisa, for all your hard work on putting energy to the grid. We appreciate it. You know, us cavemen out here, we need that. We still need and rely on basic energy today. So, you know what? Until we have the 0-point energy devices, whatever else we can use, great. Vanilla Isis. Now, that's a very unsettling name, given the context of what we've been discussing. I'm not sure how I should react to this donation. I think we'll just say thank you. Thank you. That's enough. Take one Tac Tundra. Thank you very much. Project Marauder, 1995 US DoD. Put some of that info in the Discord, and we'll take a look at that. Oh, we have microwave weapon lasers on RQ4's fact. You know what? I believe you. And hey, another donation. Sandia Labs has made it. I also believe that too. You don't even need to present evidence. Sween, just a heads up, Ashton references to Eric Davis confirming ZPE in Age of Disclosure. Yes, I've seen the notes on Age of Disclosure, and it does seem like Hal Puthoff and Eric Davis are getting more bold about how they confirm 0-point energy, which can explain, in my opinion, and I think we talked about today, a lot of the anomalous effects and claims that were made in cold fusion. And then last one, Lisa, thank you for that third donation. We're all about to get rounded up and sent to Diego Garcia. I hope not, guys. No live stream on Friday. Instead, it's going to be a restream of the evidence stream, I believe. And then potentially we'll do an edit of this one as well. We will see. So once again, thank you very much, all my guests tonight and everybody, MH370X, all the people watching. Thank you all. Have a great night. Peace out, everyone. Later. Let's go with
infrared eyes, scanning the black, tracking the heat, never turning back. Control 22, a covert gaze. Control 33, in the cosmic maze. Controls in the mix, secrets untold. Silent watchers, brave and bold. In the shadows, they silently glide, protecting our interests, far and wide. As Pierce, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. In the silence of space, they keep their post, shields unseen yet feared the most. With precision and speed, they warn of danger, keeping us safe from the missile's anger. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. And roles in the mix, secrets untold, silent watchers, brave and bold. In the shadows, they silently glide, protecting our interests, far and wide. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses